Hello. Hello. I, res- I request all participants to be seated on their chairs first. I request all participants to occupy their seats on the chairs. Please be seated. All dear participants, come forward. Dear participants, occupy the seats on the chairs in a front way. In a front way. Please have a seat. No. नहीं Right, right. ठीक है? I request all the participants, please be seated on their chairs. Occupy the seats in a front way. Welcome to Ananta Auditorium Hall of Shri Shivaji Science College, Amravati.
Check.
A very good morning and a warm welcome to one and all present here to this
Check,
second day
check.
technical session of 2 days National Conference of Earth, Elements and Energy, Interdisciplinary Perspectives 2025. Honorable dignitaries, learned delegates, respected faculty members and participants, I, Ms. Rakhi Bankar, Assistant Professor, Department of Chemistry, Shri Shivaji Science College, Amravati, and it's my absolute pleasure to be your host today. So on behalf of organizing body, I extend a hearty welcome to the National Conference on Earth, Elements and Energy, Interdisciplinary Perspectives 2025, organized by Department of Chemistry, Physics and Geology, catalyzed by PM Usha, DBT Star College Scheme, sponsored by Amravati University Chemistry Teachers Association and Association of Chemistry Teachers in the beautiful city Amravati. First of all, I pay my sincere tribute to the founder president of Shri Shivaji Education Society, Dr. Punjab Rao alias Bhau Sahib Deshmukh, and a social reformer, Santa Garge Baba, to welcome you all to the second day technical session of National Conference on Earth, Elements and Energy, Interdisciplinary Perspectives 2025. As a host, my task is to guide you all through this event, making sure it's a memorable one for everyone involved. But before we plunged into the agenda, on behalf of Honorable Principal, Shri Shivaji Science College, Amravati, Convener, Organizing Secretary, co-conveners of all respective departments and all organizing committee members, I would like to extend my warm and heartfelt welcome to our Honorable Chairperson and invited speakers of today's technical session. We are truly honored to be your presence today, and we are thrilled to have you share this momentous occasion with us, and we thank you for taking time out for your busy schedule to extend your support. Your esteemed presence has indeed glorified the sessions and added a vibrancy to our humble gathering. With that, we are ready to kickstart our event filled with knowledge and inspiration. Now I would like to invite on the dais, our esteemed Honorable Chairperson of Second Day Technical Session, National Conference on Earth Elements and Energy, Interdisciplinary Perspectives 2025, Dr. P.B. Raghuvanshi Sir, Professor and Head Department of Chemistry, Brijlal Biyani Science College, Amravati. Please, sir, welcome on the dais. Please come on the dais, sir. We are honored and delighted to have you guide us through this important event, sir. Your expertise in the field of chemistry has greatly inspired us, and your presence adds immense value and dignity to our proceedings. Thank you for accepting our invitation and for being here with us today. We are eagerly looking forward to your insightful guidance and leadership to make this conference a great success. Dr. P.B. Raghuvanshi, sir, I would like to invite Dr. P.B. Raghuvanshi, sir, please, okay. Now I would like to call respected Dr. A.B. Bodade, ma'am, to welcome our Honorable Chairperson, Dr. P.B. Raghuvanshi, sir, by offering a sapling along with a memento as a token of gratitude and appreciation. Thank you so much, respected ma'am. Now I would like to invite respected Dr. S.A. Vadar, sir, Joint Secretary, National Conference on Earth Elements and Energy, Interdisciplinary Perspectives, to give a brief introduction of our Honorable Chairperson, Dr. P.B. Raghuvanshi, sir. Dr. S.A. Vadar, sir.
A very good morning to all of you. On behalf of organizing committee, I welcome you in this national conference, NC E3IP 2025. And I am delighted to introduce the chairperson for today's plenary session, Dr. P.B. Raghuvanshi sir, Professor and Head of the Department Chemistry, Brijlal Biyani Science College, Amravati. Sir has 35 years of teaching experience for PG and UG students and 32 years of research experience. He has published 94 research papers in various reputed research journals. Under his supervision, total 14 students has been awarded PhD degree and 7 students awarded MPhil degree. He has published 10 books and he has a membership on different prestigious organizations and bodies. I had like to welcome Dr. P.B. Raghuvanshi sir and thank him for sharing his time with us for this national conference. Thank you, sir.
Thank you so much, sir. Your thought-provoking address set a perfect platform for our speakers to deliver their presentation. Now it's time to welcome our first speaker of the second day technical session of 2 days NC E3IP 2025, Dr. Ananta Kapadi, sir, Professor, Institute of Chemical Technology, Mumbai, and a renowned expert in the field of research, synthesis, and catalysis. Sir, we are honored to have you here. Sir will join with us through online mode, through virtual mode today. And we are looking forward to listen your presentation on the topic based on laboratory to market development of catalyst reagent for solving key research problems. So now I would like to invite Dr. Ananta Kapadi, sir, through virtual mode. He will join us through virtual mode. Dr. Ananta Kapadi, sir.
Thank you very much. Are you able to hear me?
Yes, sir, we can hear you.
Yeah, I'll just start with the presentation.
So now I would request to Honorable Chairperson, Dr. P.B. Raghuvanshi, sir, to welcome our first speaker, Dr. Ananta Kapadi, sir.
I welcome you all for this technical session. In this technical session, 3 research persons are there. The first research person, Dr. Ananta Kapadi, who is joined us by virtual mode, and he is presently working as a professor in the Institute of Chemical Technology, Mumbai, He has a 13 year of research and teaching experience in the areas of organic synthesis, catalysis, nucleosides, nucleotides, product and process development. Under his super able guidance, 14 students are completed a PhD degree. He has published 144 research paper with citation index 8500 and H index is 40. He has awarded by many awards and recognition. The main are Professor M.M. Sharma Award of Science and Technology 2023, Best Teacher Award ICT 2023-24. He has completed the many research projects. Out of that one, 7 are government sponsored and 5 are industry sponsored. Some are international projects. He has many collaboration with academic and industrial industry. Now I request, with this brief introduction, I request Dr. Anant Kapdi to start his talk. He has 30 minutes for his presentation. Thank you.
Thank you very much. I would like to thank the organizers for, first of all, giving me this opportunity. I would like to apologize as well for not being present personally. I was rather on my way yesterday, but I was not well. And I'm really thankful to the organizers for arranging this online talk. So I'll try to go through the work which we have done. I'll be a bit brisk because the timelines are short, but that's not a problem. As you can see with respect to slide, you can see the slides, right? The slides are visible to everyone?
Yes, sir.
Yes, okay. So when it comes to the work, what we have done for last 13 years, I think the title kind of gives an idea that we have been working with not just academic partners, but also industrial partners, working on some key scientific problems. And somewhere over the period, this association with various, people, scientists, that has allowed us science to be even made more commercially viable. We have also commercialized something. So I'm going to discuss all this part of how a laboratory idea, something which is simple, something which can be elaborated upon, and over a period of time that can become marketable, and you can then gain benefit out of it via collaborations and applications. Something which was already discussed about my work, we have been working on nucleoside chemistry quite a lot. So I'll go briefly through this area first, and then I'll come on to some applications as well. If you see the slide, I think these are the general basic nucleosides of uridine, cytidine, guanosine, adenosine. Although these molecules on their own are not fluorescent, but when it comes to the functionalization of these molecules, as what has been done here, these are simple reactions which you can carry out: Son-Geisler reaction, Suzuki coupling, Foucault-Hartree combination, and you can functionalize this molecule very easily. But the main idea is when you're functionalizing it, what are the applications which can come out is, first of all, they can be made as fluorescent probes. This can be helpful in detecting proteins, in detecting viruses by the oligonucleotide or the DNA type of diagnostic tools. Synthesis of these molecules are also important because many antiviral agents, I think the recent one for COVID-19 were remdesivir as well as favipiravir. So these structural features are very important in drug molecules of anti-cancer, anti-HIV. And in such a case, what can we do in order to improve the reactivity of process in case of nucleoside development or functionalization? What we have seen in the literature is, for many years, most of the time the reactions have been done in organic solvents. So one of the part which was there in front of us was when we are collaborating with the company, Rasayan Incorporation, is an American company. The idea was to develop processes mainly in water. And there are certain important points because organic solvents majorly used are all volatile solvents, and on large scale, it always causes problems currently with respect to environment as well. Water in that sense would be easily available, cheap solvent, but the most important point is how we can even recover solvent, because the commodity as a water is also not so easy to get pure water as such. But we had certain ideas, so we started working with certain ligand systems or structure. This is one of them. This is what is called a triazophosphoadamantane. It's a K structure. So K-phosphines was something which I was very much interested in exploring. This is also something which is very well known, TPPTS, but in most cases, TPPTS, although with combination with palladium was used, it was done in most of the organic solvents, not in water. This has a decent water solubility as triazophosphoadamantane. And we started with our first generation. This is in collaboration with Jose Serrano from Spain. We created the structure. We saw that the water solubility was decent, but the reactivity, although was good at 80 degrees with respect to cross-coupling reaction of various nucleosides, it failed to allow the isolation of the product without column chromatography, which is again a requirement of companies that you should not use column chromatography. And the main reason was there is still more hydrophobic structural feature which is present on the catalyst. This ligand is also not appreciably water soluble. And in that case, you will see some contamination of the palladium if you try to isolate the product without column by direct filtration. There is a reason why filtration could be useful, because when you have nucleosides, they are sugar-based structures. So you have a base and a sugar, but then generally they are water soluble. But once you start putting hydrophobic groups on various positions, they start becoming hydrophobic. They have less affinity for water, and they start coming out as nice solids. And that's where you can easily isolate them without column by simple filtration. Idea was very simple. Can we try to derivatize this further into a highly water soluble ligand system? And we are able to do it very simply. This is called a Saltone cyclic sulfonate, and then you can simply allow one of the nitrogen to attack. It ring opens, and you get what are called as zwitterionic sulfonates. This is highly water soluble, coordinates very effectively with palladium, and then you can get catalysts which are water soluble, have more affinity for water. They will not have any kind of coordination or latching on to the hydrophobic structures of nucleosides. And we're able to achieve the reactivity very well, isolate the product without column, because the catalyst now has affinity for water. We have done a commercial level process with a company called Safala Organic. This is in collaboration with Rasayan. Chemistry was a simple Heck reaction, but this molecule is commercially very important, called as Ruth linker. Certain problems which the company was facing, that the reaction was being carried out at very high catalyst loading of 10 mole%. So one of the aspects was to reduce the catalyst loading, increase the purity of the amount of the product, and then at the same time isolate it without column chromatography. So we were able to carry out the reaction very effectively using palladium and PTBS. One of the key features was this DMT protection, which takes place on the 5' position, which is a problem because acidic workups are not allowed in this case. This will simply deprotect. There is always a possibility of cleavage of this glycosidic bond because of temperature. So mild conditions have to be employed in order to have reaction to go forward. We are able to scale up the reaction in the lab at up to 10 grams, while we have demonstrated in the company this can go up to 100 grams or 1 kilogram very effectively. The reaction can be isolated without much problem. You don't need column chromatography. There is a process called as trituration. So anti-solvent method, which is the highly polar solvent, dissolve, and then use toluene as a non-polar solvent to precipitate out your product. So this is what you get, almost 97-98% high purity product that you get without column. So this gave us a lot of confidence, but nucleoside chemistry has its own limitation. So we thought we would rather go into some other area, but we also had some other challenges which were in front of us, mainly the carboamidation chemistry. This was done in collaboration with Professor Bangay for former HODs. He is now the Vice Chancellor at MS University of Baroda. And this reaction also was to be carried out at very low temperatures and catalyst loading of 1 or 2 mole%. But at the same time, the pressures generally utilized were very high, of 100 to 150 psi. We were able to reduce this to only 40 psi. Reactions work very well, and you can get specific commercially useful products in very high yields, even if you have DMT protection present here. We then ventured into a more open area. Nucleoside chemistry is a very niche area, but heteroarene functionalization is more open. much bigger area because there are many drug molecules which are available. Simple example in the case of CO bond formation, that you have many of these structural features which are commercially useful drugs as well as agrochemicals. Arene, so arene CO bond formation where chloro, like arenes, iodoarenes, bromoarenes, they are well known. And then you can functionalize it using the general CO bond formation using palladium on copper. These are the key players in this area. There's something which is at the bottom which is very interesting, that fluoroarenes are still effective and most of the time even room temperature protocols are known. But when it comes to chloroheteroarenes, where you put heteroatoms, nitrogen atoms, sulfur atoms on 5-membered and 6-membered rings, then the chemistry has not been so effective. Many times the reaction temperatures are higher, the reactivity has been suffering, and the catalyst loading has also been very high. If you look at the structure, they are all highly electron-rich phosphines. So whether that is one of the key features which is hindering the reaction, where the palladium or metal try to coordinate more towards the heteroatoms as kind of ligands, and that shuts down the reaction in some way. Although it is known that Buchwald has been able to achieve at around 60 degrees, and we thought that we could try to achieve it at the same temperature or lower, but in a faster reaction time. So what we are able to achieve is, you can carry out reaction with this ligand system with palladium as combination and do it at 60 degrees. We tried at lower temperature, it didn't work that well, but the reaction goes in 1 hour rather than 24 hours or 12 hours, what was reported commonly. Now, there is something about the structural feature is slightly different than what we have seen previously. If you see, they are all sigma donors, powerful sigma donors, but this one, the phosphorus, doesn't really seem to be a sigma donor. That we will come on to discussion after some time. But you can have a variety of the structural features, commercially available molecules, estrone, estradiols, and various other structural features that can be functionalized very effectively. That was not where we stopped. We wanted to go further. So you can then functionalize amino acids such as tyrosine. So we were able to do that with a variety of these chloroheteroarenes, again at 60 degrees, slightly elevated timelines of around 3 hours. The reaction works very well. But then the question was, can we go further into peptide chemistry? And we have been able to functionalize the tyrosine-based peptides, dipeptide, tripeptide, and now we have even got pentapeptide working very well in what is called as a late-stage functionalization of peptides. The pentavalent, like the pentapeptides, some of them are also drug molecules, and we are looking at functionalization of drug molecules as well in collaboration with an institute in Berlin, possibly to come out with alternatives for the current based drugs, peptide based drugs. The action works very well, and you can functionalize with variety of these heteroarenes. This is something which we are just venturing into, polypeptides or macrocyclic peptides. Idea is there are already a lot of examples of macrocyclic peptides which have been commercialized as drug molecules. Now, we were rather looking at from two aspects. One could be a possible drug which has good activity, but at the same time, introducing this heteroarene moiety would allow certain type of drug molecules, small molecule drugs, which can be incorporated into the cavity by hydrogen bonding or pi stacking. And that can be a delivery system for a variety of small molecule drugs as such. Because peptides are very easily absorbed into the cell, this could be a good carrier as well. So this is something which we are looking at. We have got some preliminary result where we see that the reaction does work, but there's still quite a lot of work still to be done. We have also ventured into CS bond formation, and the reason for this is very crucial. Sulfur in many cases acts as a poison for palladium or even other metals, especially nickel. And many cases, the reactions which have been talked about in literature, the reactivity of these either aromatic thiols or the aliphatic thiols has been suffering. But in our case, the reactions are very effective. We are getting very good yields of the product. Again, question comes for the fact that most of the reactions in literature are using metal with a highly electron-rich phosphine. So whether your phosphine, which we are using, doesn't have that problem, it's probably less electron-rich, but what we see is probably it's not electron-rich at all, it's more of a pi acceptor. And why is it so? That if you look at the structure here, or even here. If you see the cottonization of this nitrogen puts an electron withdrawing or an electron pulling group next to the heteroatoms, either this nitrogen, that nitrogen, or the phosphorus. Then the question comes that in first case, when you are trying to do the alkylation of the nitrogens, why is it that we are getting only mono alkylation? And that's where the reason comes that when you have this the cottonized ammonium, it will pull away the electron density from all these heteroatoms, making them deficient. So both these nitrogen atoms should also not be basic enough to attack. That's why your di and trialkylation doesn't happen. And naturally, the phosphorus also will lose its electron density. So it's no more a sigma donor. It could be more of a biacceptor, which means that it can coordinate very strongly with palladium. Palladium with D10 can put electron density back. It can stabilize the palladium phosphorus bond, and because of the solubility, it will then be in solution phase. Sulfur generally does the same. It has an empty d orbital, so it can chelate with palladium to stabilize the palladium sulfur interaction or nickel sulfur interaction. But your phosphorus has already done that. So the possibility of sulfur becoming a poison is less. And that's why we are getting very high yields. But then our focus was on the CN bond formation, more of the amination chemistry. And reason are more obvious. It's a Buchwald-Hartwig amination reaction. Variety of structural features are already known. Buchwald himself, his group has already published quite a lot. Many ligands are already known in commercial market, but this Pepsi, palladium Pepsi by Michael Organ also is very well known. And if you see again the chloroarene chemistry, room temperature protocols also very effectively done. Somewhere the heteroarenes were also having some problem. Higher temperatures, low reactivity, less number of substrate scope. Although there are more applications of this heteroarene in drug chemistry. So we thought, can't we explore this? But rather than going for like a 60-degree protocol, we were able to achieve a room temperature protocol just in 4 hours. And then again, you can have a variety of structural features functionalized with secondary amines. Nowadays, even primary amines are working very well. And you can have a lot of applications of this chemistry in drug discovery and even peptide chemistry, as well as in case of the nucleoside chemistry. This is where the next switch came. Companies have always been collaborating with us, and we have this unique program in ICT of having company-sponsored candidates. So the company employees who want to do PhD, who have completed the masters, have 10 years experience, 5 to 10 years experience, but have not been able to complete their PhDs. They can register under any professor in ICT, and that's how I got in touch with Aether Industries, which is in Surat. This is Uday, one of the company personnel who wanted to do PhD. What we are able to achieve was one of the key criteria set by Aether, that rather than going with palladium chemistry, can we go away from palladium and try to work with copper? Copper is cheap, it is easily available, it's an earth abundant metal, and probably the future. But it's very easy to talk about it on paper. To work on it and to come out with a better protocol is not easy, and that's what Uday did. He extensively worked with the optimization of the process, and finally we were able to change from palladium to copper rather than using any solvent. Now we are working in water itself as solvent, room temperature protocols. Most of the structures what you are seeing are not being isolated by column. They are being done by process chemistry, isolation procedures, and that's why even highly complex anti-cancer agents can be functionalized very effectively. We were able to also achieve very high recyclability of the catalyst. Although it's homogeneous, so you can go on replenishing the substrate, and then it still converts very effectively, almost quantitatively all the time. Interestingly, another group, which is Dewey Ma group from China, has been working extensively in this area, a lot of contributions. And that's why we thought that we are just entering this area, and we went on to do quite a lot in the next few years. Buchwald was always been working on palladium, but interestingly, we don't have to take the credit, but probably that was expected that probably Buchwald will come with a copper-based protocol. And in 2023 and 24, we saw 2 papers coming out with copper-based amination with respect to this ligands that was synthesized in the group. So we thought that this is the right area, but now we need to understand further exactly what's happening. So we got some information from DFT calculations and whatever predictions we had made that the phosphorus is electron deficient in case of PTABS, as well as this other analog which is there, and it does show that it's more electron deficient. It cannot donate electron density, while PTA as well as all the sigma donors can easily donate. You can see the electron mapping as well. If you see PTA, it's on the phosphorus, but in case of PTABS, the phosphorus is kind of deficient, as well as the nitrogens, while the sulfonate is showing the electron density. So if it is a pi acceptor, there is a very simple test that we did. You just carry out a reaction of the phosphorus ligand with selenium powder. The reaction works very well. Then you isolate, take the phosphorus NMR, you take the J values because there are satellite peaks of selenium with phosphorus. When you get the J values, you will come to know that the sigma donors all are below 800 Hertz, while ones which go above 800, most of them are defined as pi acceptors, and this is where our PTABS selenium lies. This is a short video where we started arguing whether there is some influence of the ligand, the electrostatic attraction between the sulfonate and the heteroatoms which are present, the quaternary ammonium, which makes it slightly more compact. Because there was an indication from DFT that the cone angle of the ligand around the metal is not much. It's around 120 degrees, which is very short, very small. And maybe the question was exactly what could be hindering this, and whether this is kind of solution phase electrostatic attraction between the sulfonate as a negative charge and then quaternary ammonium on the other ligand and make it slightly more compact. This is just an idea to give, probably think about it. We have got some evidence further. We did more reactions. We have done more amination chemistry. This is what is called as in situ chemistry, rather than using dimethylamine as a gas, which is highly corrosive. Generally, we get it from cylinders. We generate the gas using simple dimethyl formamide as a solvent and attacking it with a base like potassium tertiobutoxide. It releases dimethylamine as a gas. You get also carbon monoxide, but dimethylamine is a more powerful nucleophile. So under the condition with copper PTABS, you are able to get amination of these heteroarenes. Reason being, they are very important molecules commercially, and you can use them for synthesis of such molecules as well. We have done some more work where you have either regioselective or chemoselective problems on the chloroheteroarenes. So you can imagine these two chloro groups in the second and the fourth position, they look very similar in reactivity because of the fact that both are present near to the heteroatoms. If you look at the DFT values of bond dissociation energies, then you will see that there is only 1 kilocal difference between the fourth position and the second position. Preferably the fourth will be more effective because this chloro is in between two heteroatoms, and that's why probably the reaction might not proceed effectively or singularly in this position. But you will not see, in case of a normal SNAR, the reaction proceeding in any selective manner. All these reactions have been also tried for SNARs, which are generally taking place at very high temperature without base, and with base it still takes around 80 degrees or more. So in this case, whether our ligand with copper or palladium can coordinate into the one of the heteroatoms, this is what our proposition was, and we can create like a bias. So it will create like a steric hindrance if it is coordinating to either of the heteroatoms. But this fourth position is more vacant, it's more available, and the reaction probably will proceed in the fourth position. And that's what we see, that when we have the coordination to one of the heteroatoms with palladium or copper with the PTABS on it, there is steric hindrance, the reaction doesn't proceed into the second position. You can selectively have functionalization of the fourth position. This was regioselective. We have done it for chemoselective as well, and we see that when you define the second position to be more reactive, then probably it is the presence of these heteroatoms makes it more electrophilic, which is expected. And then you try to compare it with variety of different functionalizations, positions which are there, where chloro, bromo, iodo. Iodo is a longer, bond length, much more reactive. Copper-based chemistry is also known for it, but the reaction proceeds again into the CCl bond activation in the second position. This is what we see as a mechanism. Just briefly to tell you that probably what we see is the copper, once it's coordinates with one of the heteroatom, it activates this second position carbon with a delta positive charge. Nucleophile can then directly attack, and then the reaction can go through a copper to promoted or accelerated SNAR. In such case, room temperature protocols are more effective. You don't need temperature or activation energy as such. We have scaled up this ligand, and then this has been commercialized. So this is one of the synthetic routes. We do it in-house with students doing 50 gram, 100 gram scale up. Companies come to us with their requirements, and we are able to provide them with the molecule. So now this molecule is available commercially through various companies. I'll quickly go to the next part. This is the last part of our chemistry. We recently have been working on the functionalization of the structural features, which is called as phenothiazine. I think just the examples can show you why it is so important. Applications throughout in OLED, metal sensing, drug molecule synthesis, dye-sensitized solar cells, methylene blue as a dye, and various sensors as well. So I think it has already been explored quite a lot, but some things which we wanted to do was to see whether we can functionalize this onto either protein or probably, let's say a peptide, an amino acid, or a nucleoside. And that can make a different level of protein sensor which can be incorporated into the cells. This is what we have exactly done. We started with the functionalization of this simple phenothiazine structural feature. And what we were able to achieve is we got this, electronically differentiating structure where you have a electron donating group, which is coming from this side, a linker, which is introduced via Sonogeshar reaction. And then you are having an electron pulling system, which is a diester on the other side. This is all a conjugated system. And what you can see is the color intensity of the compound is pretty bright yellow. So it's generally around 620 to 630 nanometers. But then we used it for metal sensing, and especially in this case, if you see copper sensing, copper 2+, especially when it is slightly more loose acidic, it very rapidly coordinates with these diesters, mainly the carbonyl groups, oxygen lone pairs. Although they are weak lone pairs, that's why copper 2+ as a loose acidic copper is very much required. But you get almost instantaneous color change from yellow to green, and you have almost 100 nanometers shift, which is taking place hypsochromic. We have done quite a lot of study on this, understanding how that effect is there. We have also tried, scavenging this copper 2+ present in this tripeptide. This is generally used in cosmetics, and we do see again a scavenging taking place. This is the color of GHK copper 2, but then you can get almost decolorization or color change very effectively. What is the future is probably to try to coordinate these molecules with copper 2 enzymes like tyrosinase sensing, or the more important point is Wilson disease, where copper 2 accumulation in case of the liver cells causes a lot of problems in humans. And this could be one way of detecting copper 2+ accumulation. So this is ongoing with a collaboration in IIT Gandhinagar. This is a recent structural feature which we have made. This is very interesting, and again, electron donating, electron withdrawing structural feature. But interestingly, it shows an aggregation assisted fluorescence. So at higher aggregation, higher concentration, you see this color, which is dark purple. And when you start diluting it, it starts becoming this orange color. So we are now assessing this material for applications into like dye-sensitized solar cells and various other applications. But this is something which is very interesting. But simply changing the electronic factors or electronic properties, you can have materials of various applications. This is the next application. We have functionalized again the phenothiazine structural feature into a very important synthon. This is what is called as a boronate ester, a boron species. This will make it like a reagent. There is an aldehyde group present here, and there is a reason for this. In case of literature, aldehyde functionality in case of detection of proteins, as well as viral detection, as well as the presence of formyl groups on uridine and cytidine, which is directly related to the aging process. epigenetic code which is there. That has been utilized very effectively because aldehydes are highly reactive and they can react with variety of peptides, amino acids, proteins, and then you can get this type of chelation. We had the same idea, but rather than making it like a peptide or oligonucleotide, which is more expensive, we thought about having a very simple structural feature, a small molecule nucleoside sensor, where the boronate ester can be coupled easily using Suzuki coupling. You can get this molecule and it shows beautiful photophysical properties in different solvents. What has been achieved in this is, first of all, protein sensing. So you take BSA, which is bovine serum albumin, the highly concentrated solution of your compound can react effectively with BSA and show you again almost 100, 120 nanometers hypsochromic shift to give you a yellow solution. We have also confirmed the possibility of formation of the imine, although imines are highly hydrolyzable, so you cannot easily isolate them. The idea would be then once you form the imine, you simply reduce that using a sodium cyanoborohydride. That's what we have done, and we have isolated this as a proof of concept that our compound does react it with amino groups in amino acids which are free amino groups. And there are various which are present in the cavity of your BSA. This is the last part. In recent times, we also are interested in exploring our compound as possible sensors in cancer cell lines. We collaborated with Professor Shriram Kanwa in IIT Gandhinagar. Structural feature is a purine, where you have the second position, which is either having a proton or you can have an amino group. And the sixth position, CCl, can be activated using Suzuki coupling, using the same boronate ester that we had shown previously. You have the formal functionality here again that can chelate with respect to the various proteins and the various groups which are present. So we have prepared two more of these molecules, again highly fluorescent molecules, around 590 to 600 nanometers. The main idea was to see whether it gives you selectivity in the cancer cell line. It has shown definitely selectivity for HOCl, which is present in cancer cells. This is one of the hyperchloric acid which forms as a part of your, which is an acidic environment in case of your cancer cells. What we see in the cancer cell lines is it has shown more selectivity or more coordination towards the endoplasmic reticulum rather than spreading into the various parts of the cell, mainly the cancer cells. While this is more effective for the purine phenothiazine, which is this structural feature where it doesn't have the amino group, so possibly the chelation is happening only through the aldehyde, and there is no competition between aldehyde and the amine. But when you have the purine with amino group, it has spread all over, so it doesn't get selectively concentrated at the endoplasmic reticulum. It starts spreading in various other parts of the cell as well. So there is selectivity what we are seeing for our specificity, you can say, where it doesn't go anywhere else for the purine phenothiazine. And it also was able to detect the stress under which the endoplasmic reticulum is there, because that's where most of the changes are happening in case of cancer cells. And that was very effectively, very sensitively, it was detected using this compound. There's more study which is coming up. We are also functionalizing this structural feature further to enhance the molecule into going into almost like a, near infrared absorptions of fluorescence. We have also scaled it up. We have just submitted a 50-gram sample to Tokyo Chemical Industries. Again, then this is done in-house. And that gives us a lot of confidence because the students are also understanding how to scale up processes, make it pure and commercialize. So this is now will be made available very soon. We are also working on some more functionalizations. We are also working on some other third generation catalysts, which are highly water soluble, but doesn't have a phosphine. So this is the third, that's the fourth, and that's the fifth generation catalyst. Room temperature functionalization of purines and pyrimidine nucleosides are now well done. And this is the last slide that we are now just entering the direct late stage functionalization of RNA, where you have a CA bond. Suzuki coupling can be carried out specifically at this position using this highly water soluble fifth generation catalyst, which we are also looking at commercialization with Sigma Aldrich. That's where I would like to now thank, first of all, my group, 14 done, around 8 to 10 who are going already. 2 of them have submitted their theses. A lot of undergraduate, masters, students, even from all over Maharashtra, sometimes outside Maharashtra, they come, they are a lot of contribution to the group, collaborators, funding agencies, companies who have appreciated and supported the work. Many times the collaborations have worked in such a way that we have changed our tracks to come into areas which are more biology oriented. That is something which is of fascination to myself and to the group. And this is where we are. So thank you very much again to the organizer for giving me this opportunity. Apologies again that I was not able to make it personally. I'll definitely make it sometime in the near future. And thank you all for listening. So if you have any question, please feel free to ask. Thank you.
Yes, so now the topic is open for discussion. Thank you so much, respected sir, for sharing such an inspiring. Okay, one question.
So, this one. Anant, very nice talk. So I have a couple of queries. So when you have this adamantine phosphine, you do the alkylation, so it does not go to the phosphorus first?
No, it doesn't go to the phosphorus at all.
Because phosphorus lone pair should be higher in energy. That's react first with the electrophile.
I think if you see the basicity, which is also known from the DFT, nitrogen lone pairs were because they are present in coordination. Phosphorus electron density was not found to be that effective. So we were not interested in phosphorus alkylation, but it's very well known that phosphorus in combination with nitrogen kind of takes the lead. So we were very closely monitoring this reaction, and most of the time we have seen that the nitrogen alkylation was happening almost instantaneously. To be honest, student was excited more into tri-alkylation. So he added almost 6 equivalents to start off with. And then when he got only 1 equivalent coordinating, then I was rather explaining him exactly why should it be happening. You can imagine that there will be a competition in the solution, but how it gets exposed, and nitrogen probably is a smaller atom, it might attack faster towards the reaction. So maybe the size could be one part of the reactivity, but we have not seen ever the phosphorus alkylation as such happening.
Okay. So second point is about this dichloropyrimidine, where you are selectively doing the reaction at 4th position. That's right. So can we do similar reaction with the 2 position by keeping 4 position free?
In the sense you want to switch the reactivity?
Yeah, switch the react. So that's basically the basic problem, which one time it goes through the Suzuki coupling, it goes to 4 position, and then if you take this relay, it goes to 2 position.
Yes, I think that's where we are looking at, because amination kind of follows the same path. Second position, if you see the coordination pathway which we are looking at, when you have chloro, 2 chloros, the second and the fourth, and the nitrogen in between them, that cannot be coordinated because it's slightly hindered. So you have 2 chloros which are present beside it. And that's why the first position nitrogen is kind of accessible for our type of chemistry, where Lewis acidic metal will coordinate and the activation takes place. So right now what we are looking at is not using our ligand, but trying to create a mask towards that 3rd position nitrogen, and then probably switching the reactivity for 2nd over 4th. The reason being there are many drug molecules which are available which has 4th position aminating or 2nd position over a different position. We are not yet successful, to be honest, but we are trying.
Okay,
Various other
thanks.
methods.
Thanks.
Is there any other questions? Any other questions? Okay. Thank you so much, respected sir, for sharing with us such an insightful and inspiring session. Your expertise definitely adds a great value to this conference. Now I request respected Dr. P.R. Mandlik sir, to felicitate Dr. Deval Deshmukh sir on behalf of Dr. Ananta Kapri sir with a memento as a token of gratitude and appreciation. On behalf of Dr. Ananta Kapri sir, I request Dr. Deval Deshmukh to receive the memento as a token of gratitude and appreciation.
Thank you. Thank you. Thank you. Thank you.
Thank you so much, Mandlik sir. Thank you so much, Deval sir. Now it's time to invite on the dais second speaker of the second day technical session of 2 days National Conference on Earth, Elements and Energy, Interdisciplinary Perspectives 2025, Dr. Sanjeev Zhade sir, Professor, Department of Chemical Sciences, Indian Institute of Science, Education and Research, Kolkata, a renowned expert in the field of development of new pi conjugated system and their applications as materials for energy harvesting and organic electronics. We are honored to have you here, sir, and looking forward to listen your presentation on the topic based on pi conjugated systems as a photocatalyst and organic semiconductors for organic electronics and devices. Now I request to our honorable chairperson, Dr. P.B. Raghuvanshi sir, to welcome our second speaker, Dr. Sanjeev Zhade sir, by offering him a sapling. Dr. Sanjeev Zhade sir. Thank you so much, respected sir. Thank you so much. Now I request to our honorable chairperson, Dr. P.B. Raghuvanshi sir, to introduce our second speaker, Dr. Sanjeev Zhade sir. Please, sir.
Our today second speaker is Professor Sanjeev Zhade. He is working as a professor in the Department of Chemical Sciences, Indian Institute of Science, Education and Research, IISER, Kolkata. Sanjeev Zhade has did his MSc in chemistry from Amravati University, and then he did his PhD from Indian Institute of Technology, Bombay, IIT, under the supervision of Professor H.B. Singh. He spent his postdoctoral period in the research group of Professor Michael Bendico at Weizmann Institute of Science, Israel, with Feinberg Fellowship. Then he joined Indian Institute of Science, Education and Research, Kolkata in 2007. He is a fellow of Maharashtra Academy of Science. He has published more than 130 research articles in peer-reviewed international journals with H-index 36. His research interest includes the development of new pi conjugated system and their applications as a material for energy harvesting and organic electronics. So I invite Professor Sanjeev Zhade for his speech.
It's a pleasure to be here, and it's a privilege for me because I'm student of this place, Shivaji Science College, and I'm deeply connected with the institute. I'm visiting many times this place. Last time I came for the DST Inspire camp, there was a full hall of students of 11th standard. It was very interesting to give that talk. So I connected in way with this college. This history goes very long. When I was in the 8th standard, there was Vigyan Manch something, And then during the Diwali vacation, we were here for 5 days program, 5 days, and our staying arrangement was in the place where there is no principal office. It was just in under construction. Okay, so on the onset, I first thanks this conference convener and co-convener, Professor Mandlik and Professor Thakre. They are my good friends for a long time. And here, I also thank Professor Suryavanshi for giving the kind introduction. And here I am basically going to talk about our work on pi conjugated systems, where we use this pi conjugated system for organic electronic devices, as well as in recent year we are using this material as a photocatalyst. So, if we consider the organic polymers, it's long known that they are insulators. But it's good to start with cheers. There is long, so these three people, Shirakawa, McDermid, and Higer, this basically three different background, and they did interdisciplinary work. Higer was a physicist, and these two were chemists from the different background, but they put up their efforts together and come up with the idea that if you have the conjugated system that can conduct the electricity, and that is basically the birth of conjugated conducting polymers. So with this, when people started thinking about the conjugated system, organic system, so they basically saw that these compounds, polymers, not only the conductor, but they are very good semiconductor. And this field of organic semiconductor is basically grown enormously from last few years. For example, you see this, most of the devices, it's used silicon as a semiconductor. And it's very strong, it's very good semiconductor. It's a workhorse for any electronic devices. But there are need of some properties, like if you want to have the flexibility in the devices that we cannot achieve by using the silicon. So there we can basically replace the silicon by using the organic semiconductor. And there are many advantages of organic semiconductor. One of the basically flexibility compared to the inorganic system. And we will, on the basis of these properties, there are many applications of this conjugated system like organic field effect transistor and organic light emitting diode, which is already commercialized. Many of you are using this cell phones with these organic OLED screens. And then we have the organic solar cell and organic sensor, which can be used for biomedical applications. And obviously, for example, if we think of this figure is not looking, but if you see this not only for the basic research, it's also driving the market, and there is a growing demand of these organic semiconductors for various biomedical applications. And so starting with what we do exactly in our lab is we basically design and synthesize the pi conjugated molecules. And once we synthesize this molecule, we basically study their photophysical properties, absorption, emission. Then we study their electrochemistry to know where there is electrons and where there is empty orbital, so that we can manipulate their structure, modify their structure to get the proper properties. And then we also study their mechanical properties. I will basically show some slides on this part. And then this particular conjugated system, as they are color systems, they also absorb the visible light. So we can use basically for light harvesting application. And we aid this research by doing the DFT calculation. For example, yesterday my student Palak showed how we can study the organic reaction by using the DFT calculation. So now when we have the conjugated system, And one of the important aspect of conjugated system that we can change the substitution around this conjugated system and we can tune the properties. Yeah. So for tuning properties, we need to consider few important points. One of the point is your extent of conjugation. For example, if you start with the ethylene, go to butadiene and make it longer. So ethylene butadiene hexatriene is a colorless compound. Now if you go little longer, for example, beta carotene, you have that 10 single bond, double bond alternate, then you will get orange color. Yeah? Unless if you go even longer, make longer chain, polyacetylene, same single bond, double bond, it create the blue color. So that means by monitoring this chain length, that means extent of conjugation, we can basically change the property of conjugated system, and we can also basically think of designing molecule on that basis. And if we have the conjugated system, and if you go for the longer, for example, if you have thiophene, and if you make the 5 thiophenes in row coupled together, and if you go to the 6th thiophene, you will not have any solubility in any solvent. So as long as you don't have the solubility of your conjugated system, you cannot process this molecule. So that means you need, when you put the substituent, we need also think about the solubility of this. On this point, we have put lot of efforts. I will tell one of the example of this substitution. For example, if you take thiophene and put the hexyl chain at 3 position. So this is a 3-hexyl thiophene, and if you make the polymer, poly-3-hexyl thiophene. Now this alkyl chain should be at exactly 3 position when it coupled to the next molecule of thiophene, and that you get regio-regular arrangement. So if you have regular arrangement, then you can see this chain of polythiophene stack very nicely, and that create very interesting electronic property to this one. So electronic properties basically depend on the hopping of the charge from one chain or one layer of molecule to another layer. And for that hopping, you need very nice interaction between the molecule. And if you have this arrangement regio-regular, they will stack very nicely and will give you the basically good electronic property. But there is an inherent problem that if you take these 3 substituted thiophene, make the dimer, you will have 2 different isomer. And if you make basically polymer, they will completely random. You will not observe any electronic property. So they need very specific strategies to make these polymers. So then what we ask, basically one question, that can we put the substituents at 3 and 4 position so that we don't need to think about the unsymmetry in the molecule. So we will get the, so what we see, if you take the very small substituent like methyl at 3 and 4 position, and if you optimize this molecule, you can see this is completely zigzag random. Yeah? But then again, this DFT calculation helped us to think about what kind of substituent should we put on 3 and 4 position. And then we saw that if you put the substituent in the form of 5-membered ring, it nicely make the pockets of this 2CH2 group at 3 and 4 position, and then you get very nice arrangement without losing the planarity of this conjugated system. Once you lose the planarity, you will not get the conjugation. So on the basis, we have basically devised the synthetic strategy. We thought of taking 2-acetylene, making the metalol, and then using this metalol, we can basically convert this molecule into this cyclopentane substituted thiophene. My student Saumyajit, who is now associate professor in IIT Ropar, he was a very talented student. He has put this thing together. We have created nice polymers based on this one. Then Abhijit Agrawal, who is the student of Professor Chandak, he studied in BSc, he joined with me PhD, and my student Neha from Assam, they came up with the idea that instead of putting the metal and then kicking out by using sulfur reagent or selenium reagent, it's better to create the 2 radical and combine with the sulfur. And then we have devised strategy to So we basically use thioacetic acid, created the radical, and then this radical cascade reaction, we get this thiophene and selenophene ring, thiophene ring formation. In case of selenium, there is a problem. Once you create the radical of selenium, they combines together, or if you convert into the selenol, they are very unstable in air and water, so they will combine together to form the diselenide. So that was problem with this strategy, that we cannot replace sulfur with the selenium. So we have this substrate scope and all. So this is one of the point what I was talking is that you need a substituents solubility. Another point, if you want to tune the conjugated properties of conjugated system, we can basically use donor acceptor consent. In the previous talk, Professor Kopady was talking about they have made some donor acceptor molecules and they use as a sensor and fluorescent molecule. So similarly, what happened when you put the donor and acceptor, they basically tune their highest occupied molecular orbital, lowest unoccupied molecular orbital. So your highest occupied HOMO goes up, LUMO goes down, and you get this small HOMO-LUMO gap. And if you have the longer conjugated system, you will get the small band gap. So based on that, when Palash joined, he thought very simple problem, that take this X diazole connected with benzene, so benzodiazole, and then you have two substituent, like two aryl group. Yeah? When we change this X from nitrogen to chalcogens like oxygen, sulfur, selenium, and this peripheral group like phenyl, thiophene, and furan, you can see there is a change in color in the molecule. Yeah? So same conjugation, your length of conjugation is same, but as you are using the different donor and acceptor property, you will get all sorts of color, and at the same time you get all sorts of emission for these molecules. So going ahead, what we did basically, we have created the cyclopentane substitution. So same concept of donor acceptor we have extended to make the polymer. Now when we have this polymer, you can see the color of these three polymer. We are getting, by changing only one substituent. So in first case we have basically nitrogen, where we are replacing with sulfur and selenium. By changing one atom, that means we are doing the atomistic approach. By changing one atom, you can change color in three different, which are basically the three legs of your color diagram: red, blue, and green. Now once you have all three color, you can create all sorts of color. So going ahead, we also explain what happening exactly. For example, if you have the nitrogen in this 5-membered ring, it merely have any donor acceptor property. So it gives only one band. But when you have sulfur and selenium, they can extend their valency and they can basically shuttle through valency 2 and 4, that you get the more acceptor properties for this benzothiodiazole and benzoselenodiazole. So that way you can get the two band. One is a 5-pi star band and another is a charge transfer band. Now sulfur basically is more electronegative, it stabilize your charge separated state more strongly, and that way give the stronger donor acceptor bond, and that basically change in small this property of sulfur and selenium that makes two colors, blue and green. Going ahead, so this is basically summary on this cyclopentane substituted molecule. So going ahead, when we want to tune the properties, we can basically change the heteroatom in the conjugated system. For example, you can take sulfur, thiophene, replace with selenium, you will get basically different properties. So same concept we have used, we have created this cyclopentane substituted thiophene and selenophene, studied by their electrochemistry. Now when you have this thiophene and selenophene, which are very electron-rich system, if you put in electrochemistry and you apply some oxidation potential, it will take out one electron. So once you take out one electron, it will form the cation radical. Now if you have more cation radical, they can combine together to form dimer, tetramer, and you will get polymerization. And then you get nice if you use the electrode, you get nice polymer coated electrode. Now I can show in this next slide. You can see this is basically transparent in that video. It's a transparent ITO electrode, and you take this monomer and basically cycle between your oxidation potential and 0 volt. So once you go ahead, you will get the polymer which will be coated on this electrode. Now you can see from this spectroelectrochemistry, if you change the potential, it changes its absorbance. It changes absorption from visible region to NIR region. So at some point of time, you see this is become completely colorless. That means it's basically losing all its visible absorption, and you have only absorption in NIR region. So this is basically electrochromic property, and these polymers we can use for the various electrochromic application. For example, if you fly in some international flight, you will see that your color is changing by switching the window. There will be switch, and if you switch, it will become darker. If you switch, it will become transparent. So this kind of, it's also many mirrors we can use this electrochromic material. So going ahead, these are few basically examples based on this heteroatom replacement. So I will basically going to the next point regarding the tuning the properties of conjugated system, that is fused conjugated system. And I can tell you the one very simple example of fused conjugated system is acids. If you take basically benzene, naphthalene, anthracene, tetracene, pentacene, hexacene. So by changing this fusing, you can see this absorption is changing from 400 nanometer going up to the 900 nanometer. And this fusing basically also gives the more stability to your conjugated system, because fused systems are more robust. But in case of this particular acids, by fusing this benzene ring, instead of stability, we lose the stability. And one of the reason of losing stability, that these two part, your upper part of your acene and lower part of acene, instead of acting this whole conjugated system, it's acted like a 2-acetylene type of, 2-polyacetylene type of chain. And that creates the diradicalide nature to this system. So after pentacene, this is hardly stable molecule. So if we want to get the stability, what we can do basically, we can incorporate the nitrogen. Now one of the importance of incorporating nitrogen, nitrogen is more electronegative than carbon, it will basically gain more electron affinity. So once you have the more electron affinity, we can tune this conjugated system from P type to N type, or we can have both E and N. So we can get ambipolar property. So that was one of the aim of our work. And then you can see in the very simple, this if you go to naphthalene, acridine to phenazine, your electron affinity goes on increasing. And there is some examples of this particular. So what we basically thought, we thought of this using phenazine system, and to make the more conjugated, we have mounted 2 thiophene ring on this phenazine system, you can see. And this work was done by Abhijit. So our main aim was to make basically N-type or ambipolar semiconductors. But we got very different interesting property, and this interesting property is basically, it can be used as a mechanophotonics material. So what is happening here, for example, if you have these crystals, and what we see, these crystals are flexible crystals, and if you take these 2 crystals and this make the 2 arc as shown in the figure, and if you shine one of the end of these 2 crystals, you will get 2 output. Yeah? So it's basically multiplexing your wavelength of the light, and that can be used in the wavelength multiplexing devices. So I will go ahead and will tell what we did in this case. So our idea was very simple, take phenazine, put 2 thiophene, and for that we have made these 2 quinone molecule, benzodiethiophene quinone, and did simple imine formation reaction, ship-based reaction, and we got 2 molecules. And we also wanted to study the structure property relationship. If you have arrangement between these 2 thiophenes, syn and anti, we wanted to see how their property changes. Now here, when we did simple DFT calculation and see their HOMO-LUMO, this both molecule HOMO and LUMO look similar. And there is some literature report, for example, if you have similar HOMO-LUMO, they arrange in the crystals in the similar fashion. So indeed, what we have seen, this both molecule arrange in the crystal in the similar fashion, but they, although this molecule is symmetric, this crystal arrangement is non-centrosymmetric, and this P212121 space group is a non-centrosymmetric. And this non-centrosymmetry is important for this wave guiding property. So what we see that when this molecule arrange, they arrange very nicely like corrugated type, but there is some very weak interaction between this. Now this weak interaction basically can take this elastic strain, and then crystal can be basically either elastic or it can be a plastic type of crystal. So you can see in the next example, next slide, when we take this crystal, and we had a very good collaborator and our colleague, Professor Molla Reddy, he was working on this flexible crystal. Then Abhijit took this crystal to this lab, and what we have seen that if you take this crystal and it can be bent completely without breaking. So that means it's a completely elastic crystal. And then we collaborated another professor from University of Hyderabad, and before that we studied that one of the molecule out of these two, just by taking simple TLC plate and putting the drop of solution in chloroform, you can see below the UV chamber that one molecule shows the fluorescence, another molecule do not. And that's basically depend on the arrangement of this nitrogen and sulfur. In the second case, your nitrogen sulfur is close, so they can have this non-bonding sulfur-nitrogen interaction, and that will basically quench non-radiative pathway, and that doesn't give us the fluorescence. So by taking this fluorescent molecule ahead, what we have seen, we have taken one crystal of this molecule. So crystal means in nearly 2-3 millimeter size. And if you shine in the middle, you can see there is a glow on both ends of this crystal. So this glow is basically, that means when you are shining the crystal, your light is passing through the crystal and radiating out of at the end of the crystal. Yeah, and this basically this is wave guiding. So what happened then when light absorbs the molecule absorbs light, is passed to another molecule and is propagated, and you can see this. You are getting this at two ends some light, green color. So we are using the blue light, and you are getting the blue emission. And from emission spectra, you can see there is little changes that basically show the color change. And then our collaborator from this University of Hyderabad, he made these devices, photonic devices. He coupled these two crystals, shine the light, and he has studied basically more this crystal as a photonic molecule. Okay, going ahead, so what we wanted to do, we wanted to incorporate more heteroatom to make it more electronegative. So its electron affinity will go high and we'll get the N type of. So idea was very simple, and this work was done by my student Jasmine. And what we can see, this is a synthetic strategy which we wanted to. So at the end, what we wanted to do, we wanted to this 6-pi electrocyclic reaction and couple this, so we'll get more conjugated system. So we came up to this stage, and then we failed. So we tried many reactions to do this electrocyclic reaction, but it somehow did not work out. So then with this molecule, we again go ahead, we studied the crystal structure, absorption, emission properties, and then as I mentioned previously, electropolymerization. We also tried the electropolymerization of these two molecules. Now you can see here there are 4th thiophene unit, 6th thiophene unit. It can electropolymerize in all directions. But what we have seen here, only one molecule, which is the second molecule, is electropolymerizing. First molecule does not undergo electropolymerization. And then we wanted to know why it's happening. You can see this particular graph that each time your current is increasing in anodic as well as cathodic direction, and it's also give you the scan rate dependent current changes. So going ahead, what I saw that if you take the HOMO and LUMO of this molecule, you see that four thiophene at the four corner do not have any coefficient of your HOMO. That's why it does not go, polymerization does not go to this thiophene. Only the thiophene, which is 9 and 10 position, that takes part. In one molecule, there is a benzene ring. So benzene ring is sluggish to polymerize. It needs more potential. It's a Hershey condition. So only one molecule basically we are getting. So again, these crystals we have developed and we have studied that this crystal is flexible crystal. And then we again explain why this is flexible crystal. So for example, first molecule is stacked like a brick network. In the second molecule, you have the corrugated structure. So corrugated structure basically can absorb this strain, elastic strain. So you can have basically flexibility for molecule to rearrange. Yeah, and that way, what we further did, we have made the devices with the collaboration with Professor Satyaprasad Senanayak from NIACR, and he has studied the devices. So he made devices on PET, polyethylene terephthalate. So we can make them flexible. And then what we did, we studied this device once in the straight form, and then another time we folded it. So you can see by folding this brittle crystal, this conductivity of this molecule drops significantly. But when you have the flexible crystal, its conductivity remains same. And same thing we have observed in basically in OFET devices. And here this is basically hole only and electron only devices. So we can see the first molecule, which is the green graph, is perform better. And this device can basically, we can flex it many times and it does not lose its property. So that means what we initially thought that we can make the flexible devices. So, okay, going ahead, I have finished the first part. How much time I have? 5 minutes. Okay, I will show one small study on basically the system which were used anthraquinone. So hydrogen peroxide is a commercial commodity. It's important in many industrial application, and it also can be used as a fuel. Yeah? And it's a cleaner fuel because end product is water. So the process to make hydrogen peroxide is called anthraquinone process. So this anthraquinone process goes like you reduce this anthraquinone to the quinol, and then quinol react with oxygen to form the hydrogen peroxide. Yeah? But this process is very energy extensive, and you need hydrogen and palladium, which is very expensive. So that way, this process is not good. So we ask the question, can we use the same anthraquinone, but make the hydrogen peroxide without using basically the palladium and hydrogen. So idea was that you take the anthraquinone, couple with some donor, because anthraquinone can act as an acceptor, electron deficient system. So if we couple basically, it will give you the donor acceptor system, and you excite this molecule. So donor will take the electron, acceptor will take the electron, and there will be holes on donor. So this hole can oxidize water to form the oxygen and 2 proton and 2 electron. That 2 proton and 2 electron can combine with the anthraquinone, will form the quinol, and quinol is unstable. It will react with oxygen to give the hydrogen peroxide. So based on this idea, Nani Gopal, my student, he basically started with this derivative of anthraquinone, and he coupled this anthraquinone with some kind of donor where we have 2 thiophene and this benzotriazole unit. Now what we did, we solubilized this polymer in THF and then we disperse in water. Now when we solubilize and disperse in water, and when we studied under TEM, we can see this is forming very small nanoparticle of 50, 60 nanometer. From this graph, we can see this average size is a 40 nanometer. So this dispersed solution is basically it's called the polymer dots because it's related to the quantum dot, but we are making from the polymeric system. So this polymer dot we have taken and studied well with electrochemistry, spectroelectrochemistry. And then what we did, this dispersion, we have irradiated with light. So there is no other reagent, only your polymer dots or polymer, and you irradiate light. Now you can see if you monitor this reaction with iodine K-monophore titration for hydrogen peroxide, we can see we are getting the increasing amount of hydrogen peroxide formation. And we have calculated what is the efficiency. It's come around 2% solar to chemical conversion efficiency. So on this particular system, as we have proposed initially, so this follows exactly same mechanism. And then what we did, we extended this work to the simpler system where we don't need to couple by using some metal. So we have taken anthraquinone and resorcinol, and we have made this polymer by using hydrothermal process. And it's turned out that this particular system is even better than what we have studied previously. We have extended this work, basically whatever nanoparticle we have created from this conjugated polymer, we have used this particular polymers to do the organic reaction, particularly this oxidation of this molecule, which we can see oxazolidinone. And there are some few methods of making, but it's difficult to make this molecule. This is the study of these polymers. So what we can see this particular molecule or this nanoparticle of polymer which we have created by hydrothermal process, it can be used as a photocatalyst for this oxidation. This is one of the difficult oxidation. And we also explore the mechanism of this, and it's turned out this mechanism goes through the proton coupled electron transfer. And in this case, this donor acceptor system of polymer is important because when we want to have the proton coupled electron transfer, proton can go to this anthraquinone unit and electron will be, proton will go to the this quinone form and electron will be accepted to the anthraquinone unit. So there will be simultaneous process, proton coupled electron transfer, and we can have the oxidation of it. We also basically seen through this DFT calculation, and it looks like that all the steps in this process is basically downhill process. So this should be feasible at normal temperature. Okay, with this I came to the summary. So basically we have utilized various concepts for creating new kind of conjugated system for organic electronic material as well as a photocatalyst. Okay, thank you for listening. I will be happy to answer your questions, queries, discussion.
The session is now open for discussion.
Okay, so I have to acknowledge my student. These are students. 36, ne? Okay, yeah. So what is the question?
That is, in that particular case, what's your observation about the yield? Because in one case, the position of nitrogen and sulfur, that is, there is some difference.
Yeah.
So if you thinking about that is the field effect, it may affect that particular yield, and I think so. So what's your observation in that case?
So this emission property you are talking about.
Emission, yes, you know, that is similar.
So yield of reaction.
You have to say both the molecules.
Both the molecule. So yield is similar of both molecule. This is very easy reaction. It's a ship-based formation reaction. Yeah. So basically we have difficulty making this to quinone. That is a multi-step process.
Difference in the position, that is the, in one case sulfur and nitrogen are nearby.
Yeah.
So what is
So
the
they, it's,
density in the particular?
yeah. So,
What is the effect particularly? That's why.
so basically sulfur is a more polarizable. So it will have the vacant orbital, and nitrogen has a lone pair. So nitrogen lone pair is basically goes to the anti-bonding orbital between sulfur and carbon. Yeah. So this is like it's a charge transfer, and if you have this kind of process of charge transfer, that sometimes quenches this radiative pathway. So it will be basically your light will go through the non-radiative pathway.
There is also that is the fluorescence effect. So
Yeah.
maybe some, that is there is effect of some electron exit.
Yeah, that's true. It's mostly electronic property of this.
It was very wonderful talk, sir.
Yeah, thank you.
Have you used any different heteroatoms apart from the sulfur? Have you tried for the emulsion?
No, we did not try for that. Other than sulfur. Basically, we wanted to target this chalcogen and nitrogen, oxygen, sulfur, selenium, and nitrogen.
And the effect of transformation is here we have optimized some structure of
Yeah, that's true. We can see, but simple, we cannot see by simple DFT calculation. We have to get some sophisticated like EM calculation or something for finding out the interaction between the sulfur and nitrogen.
Thank you so much, Dr. Sanjeev Zade, sir, for such an insightful and inspiring session. Your expertise definitely adds a great value to this conference and making it more effective. Now I request respected Dr. Hemant Chandak, sir, to felicitate Dr. Sanjeev Zade, sir, by greeting him with memento as a token of appreciation and gratitude. Dr. Hemant Chandak, sir. Sir. Thank you so much, respected sir. Now it's time to invite on the dais our third speaker of this second day technical session of 2 days National Conference on Earth, Elements and Energy, Interdisciplinary 2025, Dr. Sunil Ganatra, sir, Professor, Department of Chemistry, Institute of Science, Nagpur, a renowned expert in the field of drug discovery, artificial intelligence in chemistry, natural product extraction. We are honored to have you here today, sir, and looking forward to listen your presentation on the topic on artificial intelligence in chemistry, transforming the investigation of chemical systems. Now I request to Honorable Chairperson, Dr. P.B. Raghuvanshi, sir, to welcome our third speaker, Dr. Sunil Ganatra, sir, by offering him a sapling. Thank you so much, respected sir. Now I request to Honorable Chairperson Dr. P.B. Raghuvanshi, sir, to introduce our third speaker, Dr. Sunil Ganatra, sir.
Our third speaker is Dr. Sunil H. Ganatra. He is working as a professor in chemistry, Institute of Science, Nagpur. He has a 29 years of experience and 26 years of research experience. He has guided 20 students for PhD degree and 3 students for MPhil degree. He has completed the major research project, also one minor research project. He has published 54 research papers in international and national journals. He has also submitted the 3 patents. Out of that, 1 is published. He has got many awards. Out of that, the important is B.N. Mankad Young Scientist Award by Chemical Society of India in 1992. Also, He is an International Fellow of Peace and Nonviolence. He is a member of many organizations, basically International Society for Computational Biology, Indian Chemical Society, Calcutta, and Chemical Research Society of India. He has worked as a project evaluator and referee for the project under ACRB, Department of Science and Technology, Government of India. I now request Professor Ganatra to start his deliberation.
Thank you, sir. Thank you very much for my introduction. Now I want to, lot of electrons are now moving in your head because huge amount of the research by the experts. I want to bring down your electrons to the ground state. Because right from the ground state, you can start to the new avenue. What I am introducing here is less chemistry, more a field which is in demand, which may give you a job, which gives you money, which gives you a new life, new intellect, and probably this will be the future. When I started in the 2007, I got one project from the department of this UGC project, and that project was drug discovery, anti-cancer drug discovery using artificial neural network. It was 2007. And it took roughly 10 to 12 years to understand what is ANN. Because I'm a biology student basically, then I shifted to the chemistry, but I learned the mathematics, and then I found that if you don't know mathematics, you don't know science at all. You have to learn it. And after that, I found that there are the new avenues which are coming up, and our young generations, particularly those who are in the MSc, BSc, or doing some research, they should take this path to get a best success in their life. What is that? How we can do that? I'll just explain it. Probably my lecture is for those who are in the MSc, BSc, or PhD research students. So our topic is that artificial intelligence and chemistry transforming the investigation of chemical systems. We know that when you take water and alcohol in a beaker, purely water in a beaker, we say that chemical constituents is in the beaker. When you add to that an alcohol, suddenly you feel a heat, and you say that the reaction has started. And that simple reaction has got number of parameters. And huge amount of information to that simple beaker, we never notice it. But if we notice that, we learn how they interact, why they interact, and what are the basis of interactions of science. And that simple reaction, and nowadays sir explained very complex reactions also, everything is put up in a one point that there is a data. So when you do something, whatever you do in your life, suppose you do performing some reactions or finding a new path to the reactions, you are generating data. And when you're generating data, you put this data in your research paper. That research paper is published somewhere, always demanded that it should be with a high impact factor as per the UGC and other authorizations. And then what happens, you know? They read by semantic learning. There is the artificial neural network techniques. It reads your paper, understands the concept, and store it. And then after storing all those concepts, they make a model, say ANN, and they sell you to the thousands and millions of rupees. So we use our data with all this process. But we can do that. Yes, if we start right from now. But how to do that? As I told you, it took me 12 years to understand what is ANN. So how to do that? Let's, in 30 minutes probably, we'll try to understand how we can do that. With the example also. So let us go to the next slide. This is the AI in chemistry, okay? And the integration of artificial intelligence into the chemical research is the reshaping the landscape of molecular science and material discovery. Things have already started. Probably we are very, 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 very late. People have started very fast. Okay, AI and chemistry, if you join, what you get is intelligent chemistry. And when you say intelligent chemistry gives you high precision predictions. What finally you want? You want new molecule for anti-cancer. You want new molecule for malaria or any diseases. How you need intelligence. How my system can bring that molecule very easily, very fast. So I can put my product in the market and I get money. Or at least I can serve my society, basically. So this is what you can use the AI. Modern AI algorithm, particularly machine learning and deep learning methods, enable the extraction of a complex patterns from high dimensional chemical data. Huge amount of molecules are available online, means that is on internet. Just collect those molecules and you can extract the information from that. How we can do that? There's a technique called ML, machine learning. Or there is another technique which is deeper than ML, we call it a deep learning. Things are roughly same, but techniques changes with the multi-layer system that we will learn. So MLDL, this is MLDL, is actually plus chemical data gives you understanding the pattern in chemistry. Everything is pattern in chemistry. Once you know the pattern, you can predict. Am I right or not? Suppose you know, you want to make a database, बहुत चोरियां हो रही है मान लो अमरावती में, तो पुलिस कहती है कि चोरी कैसे होती है? तो पुलिस will say that कि क्या हुआ एग्जिट 11 बजे के बाद. फिर वो चोर जो है ताला ही तोड़ता है, फिर वो चोर दूसरे रूम में ही जाता है, देन वो तिजोरी ऐसे ही तोड़ता है. So you get a pattern, and if you get a pattern, you can predict. And that pattern, learning the pattern is a mathematics. So once you learn the pattern, you can apply that pattern to your system, and then you can predict the system. That's what is ML and DL, use of ML and DL. These approaches are now being used to predict physical properties, even thermodynamical properties, kinetics, spectroscopy, and electronic properties of the molecule and materials with a remarkable accuracy. Now this is the point, remarkable accuracy. If data is good, your accuracy is good, or precision is best. If data is not good, then definitely GIGO, garbage in, garbage out will be there. So don't say. I can give you the example. You are using ChatGPT. So you ask one question, which is the first capital of Maharashtra? It will say Mumbai, very proudly. Then you say, okay, what is the second capital of Maharashtra? It will say Nagpur, again proudly. And then again you ask the question, what is the third capital of Maharashtra? It will say Nagpur. Have you tried it? You tried. What is wrong? Because it is AI. AI using the relationships, nearest approach. All this is mathematics, but it fails there. So what I want to say that, don't assume that if it is AI, it is correct. No. It may be correct. It is very near to correct. Okay? Satya jaan nahi sakte. But AI can't give you the 100% accuracy. It depends how you put up the data to that. So that is one thing. Second, sorry. So artificial intelligence and machine learning. Basically, we do the machine learning. Okay, what is a machine learning? It is a subfield of AI where algorithms learn pattern from the data. Again and again and again, I say that we learn pattern. Simple. When someone asks you the question, what is AI? AI is doing what? AI is doing nothing. It's learning the pattern. How? With the mathematics. Then it predicts. That's a simple step. Okay, but there are fields, subfields. One is a supervised machine learning and another is unsupervised machine learning. In simple way. What is supervised? Supervised means where, suppose y is equal to mx plus c. This is our equation. So we say y is a function of x. So we have got a values of x and values of y. So we got a value, suppose molarity and density. We got a different molarities, 10 molarities. For that 10 densities are available. So we know that if this is a molarity, then y should be this, density is this. So here y is available. When y is available, means result is available, we call it labeled data. We call it labeled data. When labeled data is available to you, you can use supervised learning. And this is a supervised learning. ChatGPT जो आप use करते हैं, what you are using is actually supervised learning, basically. Okay. Another thing is that unsupervised machine learning, where you don't have a labeled data. You have a group of molecules, and then you say, okay, do one thing, categorize these molecules. Then with certain properties, it can categorize it. But here you don't have Y value. So in that case, you use the unsupervised machine learning. So this is the structure. So machine learning actually gives you supervised. Generally, we use the mathematics of regression analysis. We predict the numerical values. Classification predict the categories. Okay, suppose you use a classification model, then it predicts the categories. In case of unsupervised machine learning, clustering and dimensionality reductions is there. So in dimensional reduction is that, suppose you say the 10 properties are there, it will reduce to 5 or 4 properties which are most important, and then give you the predicted model. And then reinforcement learning, this is a policeman, I can say, aapne wrong kiya, mara. Okay, the reinforcement learning is giving you the punishment. Okay, so these are the techniques. Okay, so we are just going through it because you should know which are the techniques. Now next, we'll go to the next. Supervised machine learning, okay. So what in chemistry you can do predicting solubility of molecules. Yes, it is possible through the supervised learning. Okay, and these models are available online. आप download करके आप देख सकते हैं. These are things are available. Classifying compounds as a toxic or non-toxic. Regressions for the reactions yield predictions, that is possible with this. Then common algorithm is that, this is I have written for the density data. You can have such type of equation for your data, then this equation can be predicted by the artificial intelligence and can give you the predicted model also. So linear regression or even non-linear regressions. Random forest, support vector mechanism, and neural networks. These are the different common algorithms. In case of unsupervised machine learning, this is used when you are not having the labeled data. जब आपको Y पता नहीं है. In that case, what you can say, finds hidden pattern in the chemical data set without labels. ये hidden patterns निकालते हैं. So number of things are, means you can do number with where you are not sure about that and you just want the patterns, you can use this. Okay. So example is the clustering similar molecules. आपको अगर बहुत सारे molecules हैं and you want to say cluster the similar molecules, it can do that. लेकिन मैंने बोला you can do that. It is not that much easy. You should need the complete process. Okay. And then grouping chemical reactions by mechanism, dimensionality reductions for the chemical space visualizations, and their algorithm is, this different algorithm came in clustering, PCA, principal compound analysis, and all these algorithms they are using. So basically I am introducing only two, supervised, unsupervised. And we will go with the example for only supervised. So we understand कि करना कैसे है. At least if suppose MSc students or some PhD students wants to do some supervised learning in his laboratory, he can do it very easily. How can we do that? That we'll take the example here also. Then next is the, not working. Okay. Next is the neural network. This is just like it is said that it is not 100% correct. It works like our brain works. Not 100% correct, कुछ तो भी near about है. It has got a nodes and then synapses, that means connecting the nodes. This is the nodes and then connecting the nodes, and then there is a layers. These are the layers, 1 layer, 2 layer, 3 layer, and final output layer. So we call this is the input layer, then number of multiple layers, and then output layer. As you increase the layers, then you say that you are going deep learning. If you have less minimum layers, you say that simply machine learning is there. Okay. So here we, neural network, brain-inspired computational model used to approximate non-linear chemical relations. अगर आपके पास non-linear relationships है, where you are not in a position to find out the relationship, best technique is this. It will automatically understand the relationship and gives you the predicted or trained model. So this is for neutral way. अब कुछ लोगों का question होता है. It means that one day robot will be there and man will be replaced. है ना? Question होता है. Let me tell you. चिमटा पता है चिमटा? Some we take spatula. We take a compound. तो spatula से compound पकड़ सकते हैं. Compound spatula कैसे पकड़ेगा? God अगर आपको पकड़ता है तो आप God को कैसे पकड़ोगे, है ना? So think finally it is in our control. Unless and until the properties are under controls, nothing will be wrong for that. But agar if you give the controls, allowed the controls to do something wrong, it will do the wrong. So deep learning uses a multi-layer neural network. है ना? So whenever you are having non-linear relationship and you want to predict the model, then in that case you can use neural network. Next. Other form is a reinforcement learning, where I told you that in the case of a reinforcement learning, the technique where you punish if it is doing wrong. So automatically it is going. Let take an example. कभी आप example करके देखना, बच्चों के लिए खास करके, बड़े मत करना, क्योंकि गिर गए तो परेशानी हो जाती है. बच्चे जो हैं वो आँख बंद करना, close your eyes and just walk. Do you think you will go straight? No. All the time you are using reinforce. आपका जो brain है, our brain is a reinforcement learning कराता है. अगर मैं यहाँ से जा रहा हूँ तो मैं automatically घूम रहा हूँ. मेरा brain कहता है no, next step should be like this, next step should be like this. आप कभी करके देखना, आप round circle में घूमेंगे. But it is your brain which is reinforcement learning कि you should go like this. The same technique is applied here. Okay, जैसे जैसे step wise वो आगे बढ़ेगा, as it goes to the next step, it gives you the understanding. No, this is the wrong way, so you come back. And accordingly, it is also giving the penalties. More penalties, don't go there. That is what. Second is the generative model. This is model we are using VAE, and all these models are available on internet, free of cost. You can design new molecules with that. थोड़ा सा आपको Jupyter notebook में काम करना पड़ेगा. I will show that notebook also. तो आप उसमें आप थोड़ा सा काम कर लीजिए, आप नए molecules बना करते. That molecules will be in the SMILE format. ठीक है, फिर then you can convert it into the molecular format. It is possible, but you need zinc and other libraries for that. Next, this is that back sheet, the Jupyter notebook, where we can put that coding and we can make a new molecules also. But for that you need a library of that molecules. Then you train the model and then make a new molecules. That is possible. Way model. Now, this is the very background of AI. अब समझ गए कि AI क्या है? AI is basically getting some system which can predict very accurately with high precision, which can help in my chemistry or my research purpose. Okay. So how to do that? Now we will take a very, very simple example. Very simple example. That's suppose so your teacher tell you that 1.004 molar का solutions का density निकालो. It is very difficult to prepare 1.004 molar solution because आपको पता है कि weight लेने में गड़बड़ होगी. फिर volume है, volume तो error देगा. Then you need a 25 degree centigrade, so it is again very difficult to make up the temperature at that 25 degree. It will be plus and minus. So if suppose you have a very good quality data, luckily available on internet, you collect those data, you can do supervised learning, and you can make a model. In one of the college in Nagpur, उनका problem था, हम पिक्नोमीटर यूज करते हैं या डेंसिटी बॉटल में तो पता है कैसे रिजल्ट्स आते हैं, वी नो दैट. सो वी यूज पिक्नोमीटर फॉर बेटर देन दैट. सो दे यूज अ पिक्नोमीटर, बट कुछ कारणों से पिक्नोमीटर टूट गए एंड देयर वाज अ एग्जाम. अब उनको सरफेस टेंशन लेना है तो डेंसिटी लगेगी, ओके, बिकॉज दैट इज वन ऑफ द पैरामीटर. सो वो कैसे करेंगे? सो व्हाट वी डिड, वी ट्रेन द मॉडल विद द नोन डेटा. और बच्चों को इतना ही बोला कि तुम्हारा मॉलिक्युलरिटी कितना है उधर डाल दो, एज दे नो द वेट, they get the density. Density experiment नहीं किया, but they get a very accurate density using a supervised model. How you can do it in your laboratory also? Okay, that's we will learn. So this is the application of AI in determining principal properties of chemical system. अब इसका advantage मैं आपको बताता हूँ. पानी पी लेता थोड़ा सा. The advantage of this is that once you make a system, this is a binary system, it will be valid for any binary system. For suppose I am making it alcohol in water binary system, it is valid for even other type of binary system, NaCl in water also. Because the mathematics is same, procedure is same, only the scaling will be different, so that we learn how to change the scaling or the feature changes of that particular system. But otherwise, once you make it one, you just give the data of others, you can get the results very easily. So that is what the importance of modeling the system. Now, research in the field of biology, I'm not going in the details of that introduction. Simply, I want to do one thing. My task is very simple. My laboratory is not having pycnometer. It is not having density bottle. Immediately, there is the exam. And teacher told me that मुझे density बच्चों को accurate देनी है. How you can give me? Okay, so we will train model. हम यहाँ model train करेंगे. Not working. Yeah. So problem. The problem is actually supervised machine. It is the major among the density problem. What detail में लिखा? The progress in the biological and chemical research provides a valuable physiological and chemical functionalities using the basic physical properties of life system. The major among them is density, surface tension, viscosity. All this can be trained with the one model only. However, it is not possible to evaluate the precise and accurate values of these properties for the desired concentration. Not possible. कुछ biological system में you need exact concentration, and then property. It is not possible. Okay. So method, we can go for the supervised machine learning technique. We will use that. And solution, train network to predict the physical properties of binary solution with selected variables and constant. So we will train the model. अब ये train क्या है देखते हैं अपन. And in present case, predicting the density of simple NaCl in water. एकदम सादा काम करेंगे. NaCl in water we can make in the laboratory. Suppose 10 solutions बना लिए. Actually we need to make more than 30. So suppose 30 solutions you are making from 0.1 molarity to 1 molarity, for example. And that is the range for us. Okay. So we have done that. The selected binary system is NaCl in water at 25 degrees centigrade. The selection of this system is due to its availability of quality data. Why I have selected? Because the quality data is available. Remember, you can train model only if you have got a quality data. Otherwise, you can't do that. Okay, the range of a concentration is from 0.1 mole, and temperature, of course, is 25 degrees centigrade in this case. Okay, the selected algorithm is supervised machine learning algorithm. The network trained for the equation will be this. I have used these equations, okay, d is equal to d0, because this is generally available in the literature, and they work with this equation. So, now, requirement, you need the density data of binary system. For example, NaCl plus H2O at 25 degrees centigrade. You need this data. Equation related density with the concentrations. And software you need, okay. And then mathematical equation with the NumPy library. This, you need the software and NumPy library. Hardware, personal computer, laptop with a 2 GB RAM only. So we are not using a very huge system. We are using a very simple system. Anyone can do it in the laboratory. This is the flow of our work, how it will be done. So data will go to the data procurement system, okay? The data procurement system is actually data processing, feature extraction and engineering. This is a very big subject, but I'll explain it what is that. Feature scaling, modeling, and then you are getting evaluations, machine learning algorithm, and then deployment. This is the stepwise. Remember, feature engineering is most important. Now, if suppose I use y is equal to mx plus c, there is only one x, am I right? But in case of my equation, if you see, we have done simple. X is still there, but we are featuring it that with the square root of that and all that. So you can enhance the feature of that, or you can have multivariable also. X, y, z, you can have number of variables also. So that depends on you. Now, how we do that? Okay, then once we get a data, we distribute the data. हमको तोड़ना है. Same data which is available in the literature. 70% data will be going for the training, 20% for testing trained model. जो trained model हो जाएगा उसको test करना पड़ेगा कि ठीक है क्या नहीं. So that 20% will go for that, and then 10% for validation of the trained model. तो validity के लिए. The training process accompanies the calculation of cost. इसमें here we calculate the cost. Okay. So cost is being calculated like this. This is the formula where we calculate the cost of that. And our logic is that cost should go down stepwise. So it is an iterations process. Okay, it evaluates the equation. If cost is 1, again it evaluates and changes the factor, and that cost will slowly go down between this. So cost has to come down. whereas the J is the cost, W and B are the coefficient, M is the total number of sample points. So with each and every data, we calculate the cost. Then experiment system like this. So what we have done both the systems, statistical and this one also using AI. So here you can say predicted density with the following parameters. Okay, so what is the output of our model? Output is D0, W0, W1 and W2. These coefficients values we are getting, and that is called as a trained model. And using those values, we can determine the density of any other concentrations. So you can see that the molality here, now here this is important. You can see the molality when 0, it means the density should be of the water only. So we are getting 997047 expected experimental density, and predicted is 997088, very near to that. So that shows that our model is very near to the accuracy, okay, because we are getting predicted density using those values this much, okay. So variation in the fifth place of 4-digit only, okay, whereas as you go ahead, you will find that variation is very, very less. So we are getting very accurate results with this. Now, this is now derived coefficient using supervised machine learning. There we were getting 10 to the power minus 4, okay. Yes, and here we are getting even 10 to the power minus 6, minus 5 with the AI techniques. Okay, so this is the output using AI techniques. And it gives you the values of coefficient, and when you check it, you are getting a very good accuracy. Now, when you perform this, जब ये train करते हैं, तब होता क्या है? Screen पर क्या दिखता है? So what happens when you train this? Your data will be iterated. वो लेकर equation में cost calculate करेगा. It will be calculating a cost, and suddenly you will find that your cost is very, very minimum, and then it gets a saturation point. It means that you have to stop it now. Okay. Here also you can see that the cost is coming down. After this point, the cost will increase. So further training is not required. So the graph depicts you where you should stop. This is also important. So cost is decreasing at this point. This is the minimum cost point, and also all these lines, red and these other lines, they are the values of your coefficients. So they are also taking the necessary values, and at this point, they are meeting this. So this is the point when the cost is minimum. I am taking the values of W0, W1, W2, and B. And these value we extract. And at this point, we say that our model is trained. Okay? And these values which are there, we can use it. You can see this is also a variation of individual coefficient with your concentrations. We can see all this on screen when you perform it. So statistical analysis, your R square is 0.9978, and with the artificial intelligence, it is roughly 999. It is bringing very accurate results. Okay. So next, this is the results because of the statistical and artificial intelligence. So discussion, finally, what we say that? We say that it is reported that the variance in the data calculated using supervised machine learning algorithm shows better values compared to statistical. Now you can say, sir, statistics से तो अच्छा ही आ रहा है. हमारे laboratory में तो ये बहुत अच्छा ही है. Why should we go for that? World is going for that. अगर आप नहीं जाओगे तो दुनिया आगे बढ़ जाएगी. You have to go for very high accuracy and precision. आने वाले समय में आपको जैसे मोबाइल पे मिलेगा कि आप मोलैलिटी डालो डेंसिटी दे देगा. But this simple example, I am giving you a very simple example, but in all that cases where chemistry is having a data, you can do ANN. If data are very good, you can do excellent work. Okay, how to do that? What you should learn? You should learn Python. Very immediately start learning Python. If your university is not giving this course in your syllabus, go sit with the vice chancellor, tell him that, sir, Python padhao. At least one language, Python, maybe any other language. Python is the best. Then learn ANN, Artificial Neural Network. In that, you will learn supervised and unsupervised learning. It is most important for you. and at least do this much calculation, and then pass your MSc. You will get a job. You will also get quality research associateships or better research projects, and acceptance rate is very high. I am just now retired. Abhi bhi retired ho gaya. Still I am getting 25 lakhs rupees per year for just doing ANN. So what I want to say is that learn it. It is very simple. But you need to learn a little bit of mathematics also, particularly linear algebra, matrices, Python, artificial neural network, in that particular supervised and unsupervised learning. Also, if possible, reinforcement learning. And then if you want to go for LLM model, ये जो आप करते हैं ना, कुछ पूछते हैं उसको website पे कि what is the, give me some review of this, and वो तुरंत review दे देता है आपको, ChatGPT बोलो या Gemini बोलो. What they are doing? Okay, that is LLM, okay, large language modeling है, और वो basically उन्होंने supervised learning ही किया हुआ है. But they have got a big computers, huge amount of memory, therefore they are successful in that, and because they know the correct mathematics. So start learning maths, Python, and ANN. Okay, this is the basic of that. Following the part, literature, these are the all literatures. Okay, following the part of the literatures investigated to understand the problem understand के लिए literature था. Okay, the data collected from the following research articles. We have collected the data from this research article and literature survey. For supervised machine learning, if you want to learn it, these are the literatures. Otherwise, नहीं जाना है library में, नहीं time है, कुछ मत करो. Coursera नाम की website पे जाओ. वहाँ पे deep learning के या Stanford University के ये course कर लो. AI. There are 4 courses. You complete these courses within, it will take 4,000 rupees. They charge you 4,000 or 7,000 rupees. And then you get expertise and all that. It is not difficult. Let me tell you, we are Indians. It is not difficult. Only efforts are required. So go for it. Thank you very much and wish you a bright future.
Hello. Okay, now the questions are open for discussion. Anybody have a question? Please ask. Anybody? Anybody from the participants? Thank you so much, Dr. Sunil Ganatra sir, for sharing such an inspiring session and insightful session with us. Your expertise and presentation definitely adds a great value and meaning to these conferences. Now I request respected Professor K.N. Puri sir, Head Department of Chemistry, Shri Shivaji Science College, Akola, and Secretary of Amravati University Chemistry Teachers Association, to offer Dr. Sunil Ganatra sir by greeting him with memento as a token of gratitude and appreciation. Please, sir. Thank you so much, all respected dignitaries. And thank you so much once again to Honorable Chairperson, Dr. P.B. Raghuvanshi sir, for chairing the session and for expertly guiding us through this session today. Your leadership has been invaluable in keeping our discussions focused and productive. We are grateful for your time and for your crucial role in making these sessions very fruitful. Thank you so much, all the invited speakers, for your insightful and engaging presentation. Your expertise was truly evident, and we know our participants found it very valuable as well. Thank you for sharing your knowledge and helping to make this conference a resound success. We hope this association of ours continues and strength in the times to come. Thank you so much, all organizing committee members and student volunteers who helped us throughout this process to make it more effective and efficient. Now I would like to invite respected Dr. Y.S. Thakre ma'am to propose a vote of thanks.
Thank you, Rakhi. John F. Kennedy rightly said, as we express our gratitude, we must never forget that the highest appreciation is not to utter the words, but to live by them. Good afternoon, one and all present here. I pay my tribute to late Dr. Panjabrao alias Bhausaheb Deshmukh, founder president, Shri Shivaji Education Society Amravati, and Karmayogi Gadge Baba. The wings of time seem to have flapped with a great speed, and here we are at the end of technical session of second day of the conference NCE 3 IP 2025. On this wonderful day, I, Dr. Yogita Sahib Rao Thakre, here to propose vote of thanks for the National Conference on Earth, Element and Energy Interdisciplinary Perspective, organized by Department of Chemistry, Physics, Geology, Shri Shivaji Science College, Amravati. I hope the dear participants enjoy this conference. We, the organizer, extend our sincere thanks to Honorable Chairman, Chief Guest, Distinguished Speaker, and my dear participants. I deem it a great honor and privilege to propose vote of thanks on this memorable occasion. On behalf of the organizing committee, I wholeheartedly thank respected Dr. P.B. Raghuvanshi, Professor and Head, Department of Chemistry, Brijlal Biyani College, Amravati, for chairing the technical session of the conference and also for his constant guidance, encouragement, support behind organizing such valuable conference. Thank you, sir. It's my pleasure to express thanks to our distinguished guest speaker for accepting our invitation and delivering very informative lecture on various topics and guiding research students. All the speakers really have taken effort to explain various aspects in the field of science. We take this golden opportunity to thank our first speaker, very young and dynamic speaker for this session, Dr. Anant Kapadi, Professor, Institute of Chemical Technology, Mumbai, who joined us on the online platform, deliver a lecture on laboratory to market development of catalyst, reagent for solving key research problem. Thank you, sir, for gracing the event as a guest speaker and guide us for this conference. Thank you. The second talk was started with a graceful lecture of our prominent alumni, Dr. Sanjiv S. Zade, Professor, Department of Chemical Science, IISER, Kolkata, who delivered a lecture on topic pi conjugated system as photocatalyst and organic semiconductor for organic electronic devices. Thank you, sir, for sparing valuable time for giving insight on the topic. The post-session, we have very energetic and inspiring speaker, Dr. Sunil H. Ganatra, Professor, Department of Chemistry, Institute of Science, Nagpur, who delivered a lecture on artificial intelligence in chemistry, transforming the investigation of chemical system. Definitely, this knowledge is going to have very fruitful result. Thank you, sir. Thank you very much to all expertise speakers. Our special thanks goes to Dr. K.N. Puri, Secretary of Amravati Chemistry Teachers Association, OCTA, Dr. H.S. Chandak, Chairman, Board of Studies, Sant Gadge Baba, Amravati University, Amravati, Dr. Manisha Kodape, Management Council member, Senate member, and BOS member of Sant Gadge Baba Amravati University, Amravati, and other respected faculties from the various institutions. Thank you to you all. Our sincere thanks goes to Honorable Principal, Shri Shivaji Science College, Amravati, for his continuous support and encouragement. Thank you, sir. I am also thankful to organizing committee of NCE3IP 2025, convener Dr. Prashant Mandlik, organizing secretary Dr. P.A. Nagpure, co-conveners, joint secretary, and all the committee members. Last but not least, I am thankful to all participants, respected faculty members, and dear research students for their active involvement and attending this conference with a keen eye and enthusiasm. Thank you for glorying this function. Without you, a function could not be a great success. Once again, I thank one and all wholeheartedly who worked behind the screen to make this event to resounding success. Thank you once again. Now, it's time for the poster and oral presentation. Dear friends, we know in the morning we have the poster presentation competition. I'm very happy to share you that we have got more than or above 119 abstracts for the poster presentation. Out of that, most of the posters are displayed. Now, I invite today's jury for the poster competition, and this session will continue with the oral presentation also. So I invite jury members of the poster presentation and the oral presentation. For the poster presentation, we have juries, Dr. K.N. Puri sir, Professor and Head, Department of Chemistry, Shri Shivaji Art, Commerce and Science College, Akola. Next jury, Dr. S.R. Patil, Assistant Professor, Department of Chemistry, Science College, Pavani. For oral presentation, we have Dr. Hemant Chandak, Professor and Head, Department of Chemistry, GS College, Khamgaon. He is also Chairman of Board of Studies. Also, I invite Dr. Madhukar Dhonde, Head, Department of Chemistry, Mohta Science College, Nagpur. Also, I invite convener of this conference, our Honorable Dr. P.V. Raghuvanshi sir, and other dignitaries on the dais. Thank you, sir. I feel very happy and proud to invite our beloved head of the department first, then convener of the conference, Dr. Prashant Mandlik sir, to felicitate Dr. K.N. Puri sir by offering sapling, memento, and certificate. Thank you, sir. The program is graced by our second jury for the poster presentation, Dr. S.R. Patil, sir. Now, I invite Professor P.S. Bodke, sir, Professor, Department of Chemistry, Vidya Bharati Mahavidyalaya, Amravati, to felicitate Dr. S.R. Patil, sir, felicitate him by offering a sapling, memento, and certificate. Thank you, sir. Now I invite Dr. Yanar Thakre, sir, to felicitate juries of oral presentation, Dr. Madhukar Dhonde, by offering a sapling. पुन्हा repeat. Yes, sir. कुठे आहे? अच्छा, हे पण. Add on. Thank you, sir. Now I invite Professor N.H. Bansod, sir, to felicitate Dr. Hemant Chandak, sir, by offering a sapling. Thank you, sir. Now this session will continue with the oral presentation, and simultaneously there is a judging of the poster presentation also. So I kindly request Dr. Anuja to continue the session. Thank you.
Thank you, ma'am. We will begin the poster presentation evaluation round by our respected judges. So all the participants for poster presentation are requested to remain present near their poster. The participants for oral presentation be seated in the hall. Good afternoon, respected judges, dignitaries, teachers, and dear participants. Please be seated in the hall for the oral presentation round. पोस्टर करायचं start. उर्वशी जोशी. वो CSIR लिखा है ना.
मॅडम एकदा नंबर सांगून दे. नीलिमा धोटे फर्स्ट आहे ना.
तिचंच घेते ना. निलिमा धोटेचं घेते ना. लास्ट में म्हणते ना.
मग पहिले
त्यांना त्यांच्याकडून सिक्वेन्स दे मला. मी आता निलिमा धोटेचं नाव घेते. जा.
हां आणि दुसरं कोणाचं.
Good afternoon, respected judges, dignitaries, teachers, and dear participants. On behalf of organizing committee of NCE 3IP 2025, I, Dr. Anuja Mupari, warmly welcome you all for the National Conference on Earth Element and Energy Interdisciplinary Perspective. So, we are now beginning the oral presentation. It is my privilege to invite our esteemed judges for this session. Dr. H.S. Chandak sir, Professor and Head Department of Chemistry, GS Science, Arts and Commerce College, Khamgaon, and Chairman of Board of Studies, Sant Gadge Baba, Amravati University, Amravati, and Dr. M.G. Dhonde sir, Head Shri Mathuradas Mohta College of Science, Nagpur. Respected sir, I request you to kindly take your seats. So now we shall begin with the oral presentation. Each participant or presenter will be given 5 minutes for the presentation and 2 minutes for discussion. After 4 minutes, you will get a short bell, and after 5 minutes, you will get a long bell. I request all the presenters to stay ready and maintain the time limit. So let's begin with the first presenter. I invite Nilima Dhote for the oral presentation.
Good afternoon, respected sir and all. नीचे का है फॉरवर्ड करने के लिए. Myself Nilima Dhute. I am from Kamala Nehru Mahavidyalaya, Nagpur, under the supervision of Dr. Mamta Wagh ma'am. And my topic is phytochemical richness and anti-cancer potential of Fenna reticulata leaf with molecular docking. These are the contents: introductions, objectives, materials and methods, results, discussion, and conclusion. So, introduction is that the medicinal plant Anno reticulata, it is also called as the custard apple or the bullock heart because it's shaped like the custard heart, and it contains various parts of this plant, that is the leaves, roots, stems, flower, seeds. Also, they contain the amount of phytochemicals which are present, and these phytochemicals are responsible for the various phytochemical pharmacological activities such as the anti-cancer, antioxidant, antimicrobial, all. These are the objective: to compare the phytochemical richness of ethanol and aqueous extracts, identify the bioactive component via LCMS and evaluate the anti-cancer property, then to study the interactions of compound with cancer-related proteins using docking. This is the methodology. First of all, I have collected the sample, then they air dry for 7 to 8 days, then they crush the coarse powder. This coarse powder then apply for the Soxhlet extraction. Here I have taken the 20 gram of sample, means coarse powder, and then 250 ml of ethanol. Then Soxhlet extraction was done at 20 degrees Celsius for 12 to 18 hours. Then I get the extract, and this extract then I send for the LCMS catalysis, LCMS analysis, then phytochemical analysis. So phytochemical analysis, I got phenolic content having gallic acid as a standard at an optical density, it checked at the 760 nanometer, and I got the result as 26.8306 plus 0.035. Similarly, for alkalide, I have got this, I get this result, that is the 56.74, and take a standard as the synconine, where the optical density is measured at the 367 nanometer. Similarly, for flavonoid, rutin as a standard, terpenoid, and saponin. For ethanolic extract, I got this result. So from this, I have, and it is 3 replicates, I perform this phytochemical analysis. Then identification of bioactive components by LCMS. I got the more than 100 of compounds by LCMS analysis, and some of I shown here, and which have the anti-cancer activity. Fine, because I choose the topic that anti-cancer activity, so most of the compounds shows the anti-cancer activity. This is the MTT assay of the MCF, that is the breast cancer of Aranatica ethanolic extract, and I got this Ramphal extract, and mean value, that is the 20.65 plus minus 0.22. Here, as the concentration has increases, there is a inhibition of cell growth. Inhibits, that is the motility increases of the cell, and then concentration increases, but the growth is inhibited. Now, as we know, the molecular docking is just it is a part of the computational chemistry. It is used for the anti-cancer property. As we see, the MTT assay also show the anti-cancer activity, but in by using the molecular docking, I show this is the micalamide B. It is the one of the compound I found in the LCMS result, and which have the anti-cancer property. And then by taking the protein, and then there is an interaction by molecular docking. I got this result, that is minus 7.5. It is the Wiener score, that is the binding of this molecule and ligand, and I got this binding, that is minus 7.5, having the cavity volume is 914. Actually, these two protein and ligand when combined, there are the 5 cores obtained, that is C1, C5, C2, C3, and C4 such like, means there are the 5 pockets in which ligands get fit. This is the second component, that is the alpha santonin. Here the Wiener score is the minus 8.1. As the binding score increases, that is the binding is more, means minus value as increases, the binding is more. And this is the boiled egg analysis, means it is the Lipinski. This is the Lipinski, means Lipinski shows that likeness, means if the drug is inside this yellow bulb, boiled egg analysis means the drug is inside the yellow bulb. We get it show that we can take this drug, that is alpha santonin, we take orally. It means that when the boiled egg analysis, if our drug is inside this yellow ball, we get it indicates that we drug taken orally. If it is outside, it should be also orally. But if it is inside or outside this here, then it is not taken by orally. And it is all done by the tools. These are the conclusions. The ethanolic extract shows the more phytochemical constituents rather than the aqueous extract. Also, the LCMS found more than 100 compounds, and which are the various phytochemical, phytopharmacological medicinal properties. Then IC50 value of this is 20.65 plus minus 25. Thank you. I have. Yes, sir. Sir, actually, I have identified this compound. Yes, mass.
Mass spectra.
Yes.
You have shown mass spectra. There is no mass spectra here. Oh. And how to analyze on the basis of LCMS?
No, sir.
What is the concept? What is your concept?
Actually, in phytochemical extracts, there are so many components.
Yes.
Phytochemicals.
Yes.
So I have identified just by quantitative analysis.
On the basis of mass to charge ratio, right?
Mass ratio.
Right?
Yes.
The mass ratio is the different.
Yes.
Different component having different.
Mass, right.
How to identify? Just exactly locate the mass.
Sorry, sir.
मास exactly locate होता है क्या मास स्पेक्ट्रा में है क्या?
Yes, sir. I have a result of all these, and there is a mass spectra, but I have not shown here.
So can you go to one slide back? Your this Santonin structure.
Yes.
No, previous slide. Yeah. So in this structure, there are two oxygen which is connected with the double bond and single bond.
Yes.
So oxygen has a two valency only. It can form only two bonds. How we can show these three bonds? So is it ionic form or is it
Ionic form.
so what is the counter ion then?
Sorry, sir.
So there should be salt. No? There's like a pyron structure, and then you have this. Yeah, that's true. Okay. Yeah.
Actually, sir,
Check it.
in molecular docking, I have taken the 3D structure of this, as shown here.
No, but the structure, if you have oxygen connected with three bonds,
Yes,
there
yes.
should be positive charge on oxygen.
Okay. Sorry, sir.
Yeah. So no, you can check it properly. Yeah.
Okay.
And from the mass, only you are confirming that these compounds are there.
Yes, sir.
Is that good enough to confirm that? Because I believe that there are many compounds which can have same mass.
Okay.
So merely LCMS will confirm it? I doubt it.
Means properties, sir.
No, identification of the compounds.
Identification.
Yeah. One more thing is you did your activity with the extract itself, right? Have you isolated the different component? Do you have alpha santonin or what you mentioned?
Mycamelamine.
Mycalamide B.
Yeah.
So you have that isolated compound with you?
No, sir.
No.
It is reviewed. Yeah, from reviewed.
So you just want to claim that it is there in the aqueous extract,
Yes,
ethanolic extract,
Yes.
and you just tested its
Yes.
activity with the extract. Now, there could be some sort of synergism or anti-synergism, that activity that may increase the, like two or more drugs together can enhance the activity or can suppress the activity.
Means this anti-cancer drug.
No, you have extract, right?
Yes.
You have many compounds in it.
Yes.
So you never know which compound is going to act or alone or in synergism
Yes, yes.
or anti-synergism. So these are the areas which needs to be explored to claim. I mean, cancer is something very like a hot topic, but we need to basically like more scientific in coming to the scientific conclusion. This is what I believe.
Okay, sir.
Just a suggestion for you to do.
Okay. Thank you, sir. Then, thank you, sir. Thank you, ma'am. Sir.
Thank you. Now I invite next presenter, Rohini Pedilwar.
Good afternoon, one and all. My name is Rohini Pedilwar. Today I am here for the oral presentation, assessment of heavy metal contamination and their interaction in cultivated soil of Chandrapur district, Maharashtra, under the guidance of Dr. M.S. Wagh ma'am and co-supervisor is Dr. W.B. Gurnule sir. Content, introduction, methodology, characterization, result discussion, and conclusion. Introduction. As we know, heavy metals contaminate soil, and this is a major effect on environment, and as well as the heavy metal are contaminate the plant and human being, animals also. This study I showed the heavy metal like zinc, iron, copper, and manganese, and This study we showed to what effect in heavy metal in cultivated land and how to manage the to soil. Study area, I select the Chandrapur district. There are total 15 talukas and total area cover in 11,443 square kilometer. This district have lots of industries, and also this district are farming also. I study in the cultivated soil methodology. Firstly, I collect the soil sample from different regions of Chandrapur district, and after that, dry the soil sample in room temperature, and then crush the soil sample with the mortar and pestle, then sieve the soil sample with the help of 2 sieve, then identify the some physical and chemical analysis like soil structure, temperature, and extraction with method appropriate with extract. Then after mechanical shaking, filtration, analysis, and laboratory, standard laboratory analysis. This is the characterization, pH with the help of pH meter, EC with the conductometry analysis, nitrogen analyzer, phosphorus with the spectrophotometer, potassium with the help of flame photometer, organic carbon, that is a spectrophotometer, and micronutrient like copper, zinc, manganese, iron with the help of double AS method. This is my result. Total, I collect 60 sample. Total 11 parameter I analyzed like temperature, pH, EC, OC, nitrogen, phosphorus, potassium, zinc, iron, copper, and manganese. These are total 60 samples result. In temperature are the range is the 25U to 27.2 degrees Celsius. This is a beneficial for crop and also biological activity. And the pH is the 6.7 to 9.3. These are the alkaline in nature, and this pH value is affect in micronutrient. EC is 0.08 to 0.99 ds, and this is a non-saline. These are beneficial for soil health, and OC is the 0.10 to 0.96%. They are found in the low organic matter. Then micronutrient like nitrogen, phosphorus, and potassium. Nitrogen range is the 70 to 170 kg per hectare. This is a very low to medium. And phosphorus is 4.23 to 160.6 kilogram per hectare. And these are the moderate in nature. Potassium is 106 to 353 kilogram per hectare, and this is a medium to high in range. Micronutrient is zinc, 0.30 to 4.94 ppm. This is a very low, and zinc deficiency in their sample. Iron is also moderate in nature. Copper is moderate, and manganese also very low, shows the deficiency. Conclusion: in this district, I collect the total 60 sample, and this sample shows the effect on pH, and this effect is OC, and also micronutrient like zinc and manganese. This sample, this land are not damaged, but thank you.
Okay, thank you. Can we have questions from the audience?
Okay, so in most of the cases, you are getting the graphs of which are around the mean values.
Yes, sir.
Only in case of phosphorus, this is a large variation.
Yes, sir.
Is there any reason for that?
Because fertilizers, when I collect the soil sample before a harvesting,
Okay.
That's why fertilizer came.
So some part there are more fertilizer with phosphorus.
Sorry, sir.
Okay. Okay. Yeah. Good.
What measures can be taken to increase the micronutrient level in the soil? Means you have this conclusion, but what measures can be taken for to increase the micronutrient status?
For managing, proper managing and use organic fertilizer.
Means what? Means what? Organic fertilizer means what?
Manure can be used. Manure.
Manure, organic manure.
One basic question, what do you mean by heavy metal? Heavy by density or by other parameter?
ppm, sir, parts per meter.
I mean, in what context it is heavy?
Sorry, sir.
Okay. I believe it's related to the toxic effect.
Yes, sir.
Toxicity.
Yes, sir.
Okay. Is there any relationship between, you mentioned that you found that soil is slightly alkaline.
Yes.
Is there any relationship with that you are not getting the, what you mentioned there, zinc, manganese, they are low.
Yes, sir.
Is there any relationship with the pH of the soil with the deposition of this?
Yes, because pH is alkaline nature and zinc and manganese are low.
No, why this is so? Is there any relation between the pH of the soil and the presence of certain heavy metals in it?
Sorry, sir.
There should be, because pH will decide which salt will be there in the soil. Say if highly basic soil is there, you can have hydroxides of certain metals.
Right, sir.
Okay.
Thank you, sir.
Thank you.
Thank you. I now request Mr. Ravi Dabade to present.
Good afternoon, one and all. Good afternoon, jury members. I'm very happy to present my work on pharmacological evaluation of Artocarpus heterophyllus in this National Conference on Earth Elements and Energy Interdisciplinary Perspective. Sorry. We all know that nowadays we are suffering from many diseases like diabetes, some oxidative stress related diseases, and some Helminth-caused diseases. Together, when we consider them, we understand that there is a need to have some therapeutic alternative. There are two approaches by which this can be achieved. With either we can synthesize the drug molecule within the lab, or we can isolate or extract some compounds from plants or some other biological sources. Since many decades, scientists have been working on isolation and purification of some compounds from plants. Almost all parts of plant have been explored, like leaf, roots, the bark, the stem. But unfortunately, very less work has been done within the latex of a plant. So latex is a milky substance which is secreted from a plant, especially from angiosperms. So that's why I have chosen a plant called as Artocarpus heterophyllus, commonly called as Fanas in Marathi. This, in spite of having its origin in Western Ghats of India, it does have its presence in many other states of India, like West Bengal, Assam, Jharkhand, and we should be very proud to say that India is considered to be the largest country within the world, which is actually producing 1.4 millions of disc of antibiotic as well as mylatex. And they were incubated for overnight, and these are the zone of inhibitions which we can see. From zone of inhibition, it was very clear that the antibacterial or antimicrobial activity of this particular plant latex was seen highest for the E. coli, that is gram-negative bacteria, followed by S. aureus, gram-positive bacteria, and Aspergillus niger, which is a fungus. And control which was used for bacteria was tetracycline, and for this was fluconazole for fungus. Then second, I had considered the ant-helminthic activity. For this, I have collected the earthworms from Dr. Punjab Rao Upakya Bhausab Deshmukh Agriculture College. Porthima methodology is simple. I have taken 6 to 7 sets of different, in which group 1 was control, and group 6 and 7 was albendazole, that is standard drug. And from 2nd to 5th, I have taken different proportions of latex. And 30 ml of each of this formulation was mixed with a group of earthworms. Within one group, there were about 3 earthworms. And the paralysis time and a death time was noted. Unfortunately, there is no noticeable paralysis or death time was observed for first 2 proportion, that is 1:30 and 2:30. But in 3:30 and 4:30, the death time and the paralysis time are mentioned here. But still, they are, compared to the standard drug, they are not that much good. Then the next activity was antidiabetic activity. For this, I have used the DNSA method, in which I have mixed the plant latex with the enzyme first. It was incubated for 10 minutes, and then followed by addition of starch, that is its substrate. It was also incubated for 10 minutes, and then how much is the concentration of glucose which was generated, for that I have boiled the content, and it was found out by DNSA method. Instead of acting as an anti-diabetic activity, the reverse effect was seen, that for first few test tubes, the activity of enzyme amylase was found to be increased. That means we can say that this anti-diabetic activity is not seen in the plant latex. And after 4th or 5th test tubes, the absorbance was almost constant. That is possibly because of enzyme was completely saturated with the latex, the compounds which are present in the latex. And the last was antioxidant activity. There are many diseases which are actually responsible because of increase in the oxidative stress within the body. And DPPH assay is the best method. This dye is purple in color when it is in oxidized form. When it is coming in contact with the reducing agent, it gets reduced and the color changes to the yellow. So the intensity of the decrease in the purple color will tell you the capacity of being antioxidant. And here are, with the help of a simple formula, percent radical scavenging activity can be found out, and the result was this. As you go on increasing the concentration of the latex, it is seen that the antioxidant activity of the plant is getting increased. So, in short, the anti-helminthic activity was completely nil, and anti-diabetic activity was also not present, whereas the antimicrobial activity and the antioxidant activity was seen in a good proportion. So I thank to my respected principal, sir, my research guide, Dr. Kavimandan, sir, and my head of the department, that they have allowed me to work within their lab. Thank you, sir.
Just go to the previous slide. Azun. Mage. Yes. You have mentioned the no paralysis in
Yes.
latex group
Yes.
2 or 3. What is mean no paralysis?
Well, the paralysis time is that time at which even if you shake the petri plate, the earthworm will not move anymore. Yeah.
Means
But if
only
you shake
movement,
it,
only movement, on the basis of
But
movement.
if you shake it very vigorously, then it will show the movement. That time is the paralysis time.
Okay.
But if you shake it vigorously, still they are not moving, that means it's a death time. The earthworms are dead.
Dead.
That's a death time.
You have studied the earthworm only.
Yes, sir.
278
Minutes, yes.
Means you were shaking for 278 minutes?
No, sir. No, sir. After 278 minutes, you have to shake them,
Okay,
the
okay.
petri plate.
Okay, then only.
Obviously, before that also you have to shake multiple times. If they are moving, that means still they are alive.
So every minute you need to shake and check.
No, sir. No.
Then
1 minute, 5 minutes, 10 minutes, it's up to you. But if you have just checked before 1 minute, there's no. And of course, I have repeated this for about 5 to 7 different times. But still, the largest time was this 290 minutes only. But for albendazole, the result was pretty clear within 3 hours itself.
3 hours.
Yeah.
Okay, so with this latex, you have studied different activities, anti-diabetes and then antioxidant activity. So what is the basis for this? Why you thought that this latex should show this kind of activity?
Sir, the jackfruit tree, this is a medicinal plant, and apart from latex, almost every part of jackfruit has been explored for this medicinal purposes. Only the latex part, when me and my guide has explored, very few studies or literature was available which could say that plant latex, jackfruit latex, is having this activity, that activity. We didn't get any kind of activity as far as plant latex was concerned. So we decided we will go with the plant
No,
latex.
but there should be always some basis that you will have some ingredient or some biomolecules
Exactly.
that will basically show some kind of activity.
Yeah. We need to go for a phytochemical analysis also, which will show you, which will tell us the amount of various secondary metabolites, and probably what all these activities which are shown is because of those secondary metabolites.
Okay, thank you.
So is your latex completely water soluble?
Is it? It is.
Okay.
Yes. And it's like a blood, sir. You have to collect early within the morning. If you delay the collection, the latex clot on the tree itself.
Okay. Thank you.
Thank you. Thank you, sir. Now I invite Dr. Deval Deshmukh for presentation.
Thank you. So this is Dr. Deval Deshmukh. First of all, good afternoon all. Presenting my work here, that is cascade synthesis of quinazolinone fused phenanthridinones by using multiple CH activation of quinazolinones as arines. So we know the concept of the functional group transformation where we converts one functional group into another functional group, but there are some limitations with the concept because the process is not atom and step economic. So considering the CH bond activation, that is we cleave the unreactive carbon-hydrogen bond directly without any functional group transformation by the use of transition metal complexes. So we know that the CH bond is most fundamental linkage in the organic chemistry. So activating directly that carbon-hydrogen bond is the hottest topic in the recent area in the organic chemistry. Also, there are some challenges associated with that because due to the availability of all the carbon-hydrogen bonds, the selectivity is the major concern regarding these reactions. Also, the carbon-hydrogen bond having the high bond dissociation energy, so that's why these are thermodynamically stable. So what we do particularly, we use the tethering group or the directing group in our strategy where the directing group coordinates with the transition metal complex, and the transition metal then forms the 5-membered cycle here, activating or the breaking the carbon-hydrogen bond, and then there is incorporation of the new functional group which incorporates the functional group, eliminating the transition metal there. So by using this strategy, several reports are already there in the literature. As we know, the N-heterocyclic compounds are very high importance because they are omnipresent in the natural products, the pharmaceutical molecules, then materials. Among them, the quinazolinones and the phenanthridinones having their own privilege because they are highly diverse, they are having highly diverse biological as well as pharmacological activities. So considering them, there are n number of reports already present in the literature for their synthesis, but the dual framework having the quinazolinones and the phenanthridinones are very rarely reported. So we found a scope there, that was the research gap, and hence we decided to synthesize this molecule. So in the literature, as I said, that very rare reports are there. So Banerjee and Bhanja has published one work where there was the intramolecular CN bond activation, that is the cyclization reaction was there. And again, some authors have reported the similar kind of molecule by using quinazolinone with the reactive aryl sources. So what we have done in our work, we have used the quinazolinone, we have activated the carbon-hydrogen bond of the quinazolinone, but instead of the reactive aryl sources, we have used the unreactive or the simple arene as a aryl source because simple arenes like toluene or benzene, and we have directly done the CH activation of these simple arenes. So we can see that in our protocol, we have simultaneously activated 3 carbon-hydrogen bonds at the same time, giving the desired moiety by using the palladium catalyst. So our approach is a multiple CH activation. We have no used any ligand, so ligand-free approach is there. Then highly regioselective protocol is there. The protocol is atom and step economic. Also the mild reaction conditions because we required only 50 degrees centigrade for our reaction and wide reaction substrate scope. So the starting material required for this protocol we have synthesized in our lab only. So there was one publication in RSA Advances. So we continued with this molecule which were already synthesized in our lab. So in optimization studies we have screened various palladium catalysts along with the various oxidants, then solvents, temperature and time, and optimized conditions we required 10 mole% of the palladium acetate along with 2 equivalent of potassium persulfate as an oxidant with TFA solvent, triafluoroacetic acid, 2 ml, and the temperature we required 50 degrees centigrade. So by utilizing these optimized conditions, we have synthesized various substrates of this molecule with the electron donating as well as electron withdrawing groups at the various positions. So quinazolinones as well as arenes have activated and worked very well in our protocol. So considering the mechanism of this reaction, first of all the palladium coordinates with the nitrogen and then it forms the 5-membered ring which undergoes the oxidation reaction. The palladium undergoes the oxidation. After that there is incorporation of the aryl source, and then after the arylation, in second step, we have again continued the intramolecular CN bond formation by using again the palladium catalyst. So 2 steps are there, in situ we are performing. So that's why this is the cascade type of reaction. So in conclusion, we we have activated the multiple CH bonds. After that, the reaction conditions are very mild. Then no pre-functionalization is required. And we have achieved several substrates with our protocol. So we have already applied this work for the patent. These are my publications, recent publications. I would like to thank my guide, Professor B.M. Bhandge from ICT Mumbai. He is VC right now, UGC for the funding. Then co-workers of my college, BMB Research Group, and organizers of this beautiful conference for giving me opportunity to present my work. Thank you.
So, Deval, how many compounds you synthesized?
Actually, we have synthesized 12 compounds, and the remaining compounds are still in work, means we are working on them.
Where you are working with this scheme?
Actually, I am working at the ICT Mumbai. In the vacations, I am doing that work. That's why it is happening in the installments.
And one more question, like you use TFA as a proton source.
No, TFA was a solvent.
TFA was a solvent?
Yes.
So, what other solvents you tried?
Other solvents we have tried, but the efficiency of the reaction was very less. Actually, TFA has a very specific role in the CH activation reactions. This question, the similar question I have asked to many experts in the CH activation field. So they suggested me that the TFA enhances the electrophilicity of the palladium center, basically. So that's why it requires the TFA only.
Like how come it enhances the...
Actually, this is not exactly sure, but...
Okay. I mean, do you really require an acidic medium here, or you can use some other fluorinated solvent like tetrafluoroisopropanol, trifluoroisopropanol?
Other fluorinated solvent we didn't screen. But in the previous protocols where the similar kind of reactions has been done, they have used the TFA, so we gone with the TFA only. Initially we have tried with the acetic acid and like these solvents, but in some solvents the reaction didn't work at all, and in some solvents there was very less efficiency of the reaction.
See, fluorinated solvents do play a role in this kind of oxidative addition, reductive elimination pathways.
Yes.
Especially.
Yes.
That I agree, but what is the role I cannot understand. Secondly, you use oxone as an oxidizing agent here. K2S2O8?
Yes.
Right? Oxone? Potassium persulfate?
Potassium
peroxymonosulfate?
No, only, yes, potassium persulfate we have used.
Potassium persulfate or oxone you used?
No, potassium persulfate, K2S2O8.
Okay. Have you tried other oxidants?
Yeah, we have tried other oxidants, but the same issue was the yield was lesser. I have shown the optimization study there. So as compared to the K2S2O8.
There you used other cooperating metals like copper, I can see. No. Palladium they used, but along with that.
Along with palladium, the remaining, actually we have screened. After palladium, we have tried the reaction with nickel also.
Just go back.
No, in this optimization,
show me optimization table.
Yeah. In this, we have only screened the palladium, but just for the curiosity purpose, we have tried this similar reaction with the nickel and cobalt also. But unfortunately, both the reactions didn't work. Probably, we need to change some, whatever the reaction parameters are there. But within the same, means constructing to the same reaction parameters, only palladium will work.
And in your slide, you mentioned temperature 50 degrees Celsius. Here we can see 25 degrees Celsius.
These are the initial optimization conditions are there. So in 25 degrees centigrade also we observed the product, but in the trace amount.
Table continued.
Yeah.
Okay.
So what is the exact role of this oxidant?
Oxidant?
Yeah, persulfate.
In the mechanism, the palladium is in the +2 oxidation state first, and we require that in the +4 oxidation state. So basically the oxidation of the palladium, we require the oxidant.
Palladium settling between 2 and 4 oxidation state?
2 and 4, and in the last step it goes to the palladium 0 also. It is already proven mechanism in the previous reaction, so we followed that.
Okay, thanks.
So to generate again the palladium into +2 oxidation state, there is also role of the K2S2O8.
Okay, thank you.
Thank you.
Thank you, sir, for your informative presentation. I now request Vaishnavi Gidmare to present.
Good afternoon, everyone. I, Vaishnavi Dinesh Gidmare, presenting as a PhD candidate in chemistry in the Faculty of Science and Technology. Sustainable, transparent, and bio-based flame retardant coating for cotton fabric on phosphorus-modified chitosan banana pseudostem composite. My research is being supervised by Professor P.V. Tekade sir at Bajaj College of Science, Wardha. Concern about fire safety have increased day by day due to widespread usage of this synthetic material. For a material to catch fire, three components should be there, that is oxygen, heat, and fuel. If you eliminate any one of the component, the fire can stop. Estimates, according to the estimates from World Health Organization, 180,000 people die as a result of fire each year. These severe incidents highlight the need for fire safety, and this fire safety problem can be somehow overcome by usage of flame retardants. Flame retardants are basically the components that are added to the synthetic material in order to inhibit, suppress, or delay the spread of the fire. Researchers have developed a flame retardant material in which they have used non-halogenated components, but these components have several environmental issues. Thus, there is a need of bio-based flame retardant material which is more environmental friendly. The key component of my research is bio-based material, so I have focused on a bio-based material that is banana pseudostem, because India is the largest banana producer, and the waste generated is usually disposed of by the farmers into lakes and rivers, and the high cellulose content of banana degrades slowly. All the parts of banana has several applications. The banana pseudostem has rich in potassium and magnesium. The synthesis of flame retardant material is phosphorylated of chitosan banana pseudostem, in which I have taken a concentrated banana pseudostem sap solution. Then it is treated with chitosan. The chitosan is dissolved in acetic acid. Then it is phosphorus modified and heat and stirred for 12 hours at 100 degrees Celsius, and then the prepared solution is coated on cotton fabric. The prepared material is characterized by using same EDX and TGA. On the left, the first image is of uncoated fabric. Second is of coated fabric. In elemental analysis, by using EDX, we get carbon, oxygen, phosphorus, and nitrogen. On the right, the first image is of uncoated cloth, and second image is of coated cloth. In the TGA graph, the black indicates the uncoated cloth, which demonstrates the quick wet loss and decomposition at 300 degrees Celsius, while the coated material has slow degradation and has higher thermal barrier. I have done a comparative test in which we have prepared several materials, and a comparative study is done in which banana pseudostem material is prepared, then chitosanated banana pseudostem composite is coated on material. Later it is doped with phosphorylated banana pseudostem, and lastly phosphorated chitosan banana pseudostem, and we get the better result in phosphorylated chitosan banana pseudostem, in which this is the LOI and VFT comparison. We get more LOI in phosphorylated chitosan banana pseudostem, and in VFT the material shows higher barrier to the flame, and shows the char length. This is the uniqueness of the work. I have compared my data with previous researchers, and the LOI value of my prepared material is more, that is 48.44. In conclusion, I would like to say that bio-based flame retardant material is more environmental friendly, less toxic, and it emits less smoke. If the time permits, can I show the video? On the left, it is the uncoated cloth, and on the right, it is the coated cloth. And it is given a spirit lamp test, while the uncoated cloth catches fire immediately, while the coated cloth will sustain flame up to 120 seconds. Thank you.
Thank you, Vaishnavi. Now the topic is open for discussion.
Okay, so what is this LOI?
LOI is limiting oxygen index.
Okay, so what it indicate?
It indicates that if the LOI value is more, the material is more flame retardant.
And how you calculate it?
We have given it for characterization.
Okay, there are some instrument which
Yes.
evaluate that LOI number.
Yes.
Okay, thanks.
Thank you.
Any logic for going with the banana stem?
Banana pseudostem, because it is rich in potassium and magnesium, and it helps to bring the material into condensed phase, which will lead to the char formation. And char formation will not spread the fire easily.
And you see, there is a change in the color of the fabric.
Yes.
So that will be probably pose a challenge.
No, the color is not very changed. It is.
We can see in the
Yes.
video.
Yeah, slight change.
Okay, thank you.
Thank you so much. I now request Kailas More for his presentation.
Good afternoon, sir. Thank you for inviting me. Today I am here to represent my topic, efficient eco-friendly synthesis of bioactive 1,4-dihydropyridine and their molecular modeling. Let me highlight the green synthesis revolution as an efficient catalyst for the synthesis of this 1,4-dihydropyridine. Suppose that we have to make some biological active molecule with elegant and environmental responsibility. So my work is the answer for that question, because we have synthesized the biological active molecule at ambient temperature by using silica sulfuric acid. So these are my contents of the presentation. We are complete throughout the entire presentation. This is the graphical abstract in which we have used the pyrazole carboxyaldehyde, ethyl acetate, and ammonium acetate and silica sulfuric catalyst. At ambient temperature condition, we have converted these reactant into the 1,4-dihydropyridine derivatives. Recently 1,4-DHP derivatives are synthesized by using different protocols and different catalysts, but they have the drawbacks such as high temperature, high reaction temperature, um, not a easy separation of catalyst. There is a product purification, tedious product purification. It requires more solvents. But our synthesis is very efficient because we have reacted all the reactant at room temperature with the help of silica sulfuric acid, and only by just simple filtration the products are separated and catalyst also separated, and we got our product. This is the plausible reaction mechanism in which in first step there is a formation of Novengel product first. In second step again ethyl acetate react with ammonium acetate and forms beta enamino ester second complex. These first and second complex again react with react and forms after the cyclization and dehydration we got our derivative. These are the some products we have synthesized using different pyrazole carboxyaldehyde with a different substituents, for example methyl, benzene, fluorine, nitro, fluoronitro, bromo, chloro. This is the fluoronitro, difluoro, fluoro and bromo having a high yield. This is the highly efficient product because it have a highest yield 96%, and this product is characterized by using FTIR, 1H NMR, C13 NMR and LCMS characterization, which having a 484 M by Z peak. These are the FTIR peak. These are the FTIR shows the NH, CH and carbonyl stretching frequencies. These are the 1H NMR spectrum. All the signals are matched with the our desired molecule 4A. These are the C13 NMR and LCMS analysis we have done, and we have found all the results are good with available moiety. We have also optimized the reaction at a different catalyst loading, in which we have the highest catalytic activity for the 0.10 gram of catalyst used for the synthesis, and having a 96 is the catalyst loading, but it is unaffected. So minimum optimum condition is that we have to use the 0.10 gram of catalyst. Minimum catalyst is required for this synthesis. This is the advantage of our synthesis. This is the molecular modeling analysis calculation by using mole inspiration software. All the parameters are matched with standard drugs. So one more minute, sir. These are the toxicity profile drug score calculations, which are calculated using O series software, and it also proves that all the compounds synthesized, they are highly a drug candidature for future. This is my conclusion. We have synthesized our 1,4-DSP using efficient, eco-friendly one-pot synthesis. The catalyst is easily recovered by just simple filtration method. We got high yields, and there is no any chromatographic separation technique for the purification of product. And we have also done the molecular modeling and toxicity drug scores by using O series software. These are some molecules we can synthesize by using molecular modeling, and they are the good candidature for the drug. Therefore, we focus on that. This is I extremely thanks.
Now the topic is open for discussion.
Go back. Previous slide. Yes.
This is what you are planning to do?
Yes, sir. We have calculated these drug candidates in O series software. We can synthesize using silica sulfuric acid with any other metals and some other bodies.
Where you synthesize?
Yes, sir.
Where you did this work?
I have done this work in Nabira Mahavidyalaya, Katol, under the guidance of Dr. N.V. Gandhare, sir.
Yes, very good.
So have you tried simple sulfuric acid for this reaction?
Yes, sir. Simple sulfuric acid we have used, but there is no green condition involved in this. And whenever we use the sulfuric, very catalytic amount of sulfuric acid precursor with silica, because it adsorbs over the surface of mesoporous sulfuric acid, therefore it activates, activates the carbonyl group of the reaction.
And silica sulfuric acid, you need to put it in furnace for some time. What was the temperature?
Silica sulfuric acid. Sir, just because this reaction is a hazardous reaction, therefore we have take care of that for the preparation of this, because we have to use low temperature for the synthesis. We have used ice bath for the synthesis, because jo sulfuric acid precursor we have to add. The vigorous reactions occurs, therefore we have used optimum conditions.
Okay.
Thank you, sir. Thank you, sir.
Thank you, sir. Now I request Dr. M.A. Pawar, sir, for presentation.
So good afternoon, one and all. I am Professor Mahesh Pawar, and I am presenting my research work here, which is entitled Solvothermal Synthesis of CCF at the rate graphene oxide, GO, robust catalyst for direct amidation using dimethyl formamide. So we know that in case of many organic compounds, the carbon-nitrogen bond are generally present, but this carbon-nitrogen bond is mostly present in the functional group that is known as the amide. And we know that amide is one of the most important functional group, which is present in about 80% of the organic molecule, which is synthesized or which is naturally occurring. Now it has a wide application or utilization in polymer, in agrochemical products, it plays an important and vital role in biological system as well. So it is very important to focus over the synthesis of the functionality that is the amide. Again, amide has the wide application or the number of the drugs which we synthesize or they are naturally, they incorporates the amide functionality. So here we have focus over the synthesis of the amide group, that is amide containing compounds. Traditionally, these are some method which are available in the literature. First one is the condensation of the amine, second is by activating the carboxylic acid, and third one is by using the ester as a precursor material. Apart from these methods, there are the certain catalytic methods which are available for the oxidation, for the synthesis of the amide, such as the nitrile amidation, aldoxane, which is a Beckmann rearrangement reaction, amine formylation, and aminocarbonylation. So these are some catalytic method, but these method which is available in the literature, that is traditional method, and the catalytic method, they suffer from some drawbacks like harsh reaction condition, utilization of the equal proportional of the reagent. During the traditional method, there occurs the formation of the undesired, the side product, hazardous utilization of the hazardous coupling reagent, and the most important thing is that in case of the catalytic synthesis of the amide, it faces the major problem of isolation and the reusability of the catalyst. So here we have focused to synthesize, to develop a catalytic protocol which will be eco-friendly, which will be green, and which will be easily isolable from the reaction mass. So we have focused over synthesis of this copper, cobalt, ferrous oxide at the rate graphene oxide, and this is the schematic representation for the synthesis of the amide. In the literature, when we did the literature survey, we found that the number of support material are available ranging from the carbon nanotube, metal oxide, graphene, metal organic framework. But here we have used graphene oxide as it is having the highest tensile strength, it is having high surface area, as well as apart from these things, it has the many functional groups such as the carboxylic group, epoxy group, there is a hydroxy group, so that helps for the coordination of the nanomaterial. So it is one of the most important and most widely utilized, what we can say, support material. So this is the schematic representation for the synthesis of this nano catalyst. We have used the solvothermal method, and this is the schematic representation. We have used the autoclave for the synthesis, and we have placed all these things in the autoclave, and we kept it for over a night, about 24 hours, and finally we got this catalyst. So this is the reaction scheme where we have worked, where we use the carboxylic acid and different types of that is the source of the amine. The first one is the source where DMF, that is dimethyl formamide. So then we use diethyl formamide, and apart from this dialkyl formamide, we have used the morpholine, the 4-formyl morpholine. So before going for the reaction, we have optimized the reaction condition. We screen the conditions. We have screened the catalyst in the different proportion. We have screened different oxidizing agent. We have screened the loading of the catalyst, temperature at different temperature ranging from 70 degree to 90 degree up to 100 degree, and we got the different conversion rate. So after screening, we found that the catalyst having the 1:1 proportion of copper and cobalt at 90 degree, and using the TBHP as oxidizing agent, oxidant, it is found to be a good condition, and we use that condition. And we have used different substrate ranging from the electron donating as well as electron withdrawing. We have synthesized near about 20 different amide products. So this is the comparative study of our synthesized catalyst with the literature, with the catalyst which is available in the literature. This is the reuse. The most important thing regarding this catalyst is that it is magnetically separable, and it is utilized for number of time, for about 5 times. And it is observed that its catalytic efficiency remains as it is up to the 5th cycle. Now, after synthesis of this catalyst, we have thoroughly characterized the synthesized material using different, what we can say, spectroscopic technique, that is XPS, photoelectron spectroscopy technique, then FTIR, then XRD. Again, XRD confirms the conversion of the graphite to its graphene oxide. Then we went for same EDX. Then we have again studied the surface morphology of the synthesized material, and it is consistent which we have desired. This is the characterization of the catalyst which is reused for 5 times. And this is the one of the compound which we have synthesized by using this catalyst. This is the C13 and H1 NMR of this compound. So these are the some references. And conclusion, finally, I would like to say the compound which we have, the catalyst which we have developed, it shows great catalytic efficiency, and it is found to be good in case of when we reuse it even after 5 cycles, its catalytic efficiency did not decline. So thank you very much.
Thank you, sir. Now the topic is open for discussion.
Just you have mentioned the green. What is meant by green?
Actually, when we synthesize this catalyst, we use a one-pot synthesis method.
Okay,
Yes.
but you have used the different metal.
Actually, yes, sir.
Metal.
Yeah, these metal, they act as a catalyst here. In the literature, if you go in the literature, you will find that the copper and cobalt, they are widely used.
Yes.
But we have tried to make here multi-metal oxide.
You have not tried without metal?
We screen this reaction condition in the absence of this catalyst, but the reaction got failed.
Okay, thank you.
Anyone question? Thank you, sir. Now I request Urvashi Joshi to present.
very warm afternoon to one and all present. Myself Urvashi. I'm working under the guidance of Dr. Suresh Kumar Jivrajka, Senior Principal Scientist at Membrane Science and Separation Technology Division, CSIR CSM CRI Bhavnagar. The topic of my presentation is rapid fabrication of selective barriers through layer by layer self-assembly of non-stoichiometric polyelectrolyte complexes for selective separation, presenting on the same at NCE3 IP 2025. Downward, okay, thank you. So giving a quick introduction, let's begin with the global water scenario. As we all know, there's a 70% of Earth's surface is covered with water, but only 3% is fresh, and out of which 2/3 is locked in the glacier. Thus, we have a limited accessibility. Again, by this year, as we are ending the year, 50% of global population facing water stress, and by 2030, water demand in the developing countries will be exceed by 50%. Thus, there's a rise need for the textile wastewater treatment. Why I have chosen textile wastewater? Because every year, 360 to 400 billion meter cube wastewater per year is being produced, and if it is not been treated, it would cause a lot of pollution. Plus, textile wastewater is one of the challenging feed as it contains dyes, salt, and other additives which are hard to separate. Again, if we go with the conventional treatment methods, that is biodegradation, photocatalysis, and all, these are costly and there's no recovery of the resources. Thus, there's arise a need for the selective membranes that can separate the dyes and salt, and we can efficiently recover the resources. Now, what is membrane? Membrane is a semi-permeable barrier which allows to pass the selective entities, and the transportation of these selective entities present in the solution depends on the pore size, surface charge, and surface characteristics of the membrane. On the basis of the material of construction, modes of operation, and structure of the membrane, they are classified into 4 different types, that is electrical potential driven membrane, temperature driven, concentration gradient driven, and pressure driven membranes. Now, pressure driven membrane are microfiltration, ultrafiltration, nanofiltration, and reverse osmosis. As we go from microfiltration to reverse osmosis, the pore diameter of the membrane reduces, and the molecular weight cutoff also reduces. Now, the challenge is microfiltration and ultrafiltration membrane have larger pore size, thus they cannot separate dyes and salt, while NF&RO has a smaller pore size, but they require higher operating pressure, causing concentration polarization on the membrane surface and leading to the fouling. And also the process became energy extensive. Thus, there is a gap between ultrafiltration and nanofiltration in which we can modulize the right molecular weight cutoff membrane, which are tight ultrafiltration membrane and loose nanofiltration membrane. They have the molecular weight cutoff in the range of 1000 to 5000 Dalton, while the LNF membrane has cutoff in the range of 500 to 1000. They have been prepared with the NIPS, IP, and surface modification processes, but this conventional method leads to thickening of selective layer. Thus, in my research work, layer by layer self-assembly is being explored for the preparation and surface modification. Now, what is layer by layer assembly? Layer by layer assembly is a technique which enables the formation of thin film in a nanoscale on the support material. Electrostatic attraction between the polyelectrolytes are responsible for the formation of ion pairs. Our approach was, in the earlier literature, 60 bilayers are reported. Like 120 layers of the modification has been reported to produce tough and LNF layer. Our aim was to produce it our aim was to enhance or fasten the assembly, and thus we have used the complex polyelectrolyte complex method, which are bigger in size, helps faster formation, high charge density, thus a stable attachment, and works better in the lower concentration. Now this polyelectrolyte complexes has been characterized and their stability has been checked. This photographs has been taken after 8 weeks of their formation, and we can see 4:1 to 6:1 stoichiometric ratio is quite stable. These are the same images in which quite spherical shape of this complexes can be seen, and in the atomic force microscopy AM, 45 nanometers of the size can be predicted. While in the DLS size, we can see the hydrodynamic size which has been for the excess anionically charged polyelectrolyte complex is between 250 to 360 nanometers. For the cationic, it is between 200 to 230 nanometers. While the zeta potential decreases for the anionic PECs from 70 to minus 70 to minus 48 millivolt. Just a couple of minutes, I'll take more. And in cationic, it decreases from plus 44 to plus 24 millivolt. These are the thickness of the isolated films. The isolated film is being characterized by AFM, and it shows 120 nanometers of the thickness of the total film that has been produced by LBL. This is the XPS elemental analysis, in which the base membrane doesn't show the presence of sulfur, while from representative membrane MEM PC1 to PC3 shows the presence of sulfur and nitrogen. These are the cross-sectional images of the prepared membrane. Now, as we go from the base membrane to the produced resulting MEM PEC3 membrane, the molecular weight cutoff decreases, and as we can see in the surface same images, the base membrane shows porous structure, while as we move from PEC1 to PEC3, there's no pores are visible. As these are the dry same images, and these membranes are being used for the aqueous treatment, their cryosem has also been studied, and we can see the uniform film formation. Now towards the application part, this membrane resultant has been applied for synthetic wastewater, stimulated wastewater, and real textile wastewater and tannery wastewater. We have resulted greater than 99.9% rejection of these dyes, and you can see the digital photograph E, where the feed and permeate of each are recorded, and almost greater than 99.9% rejection of dyes has been seen. Now towards the stability of this membrane, these are very stable for the 6 bars of the pressure. They have long-term stability of in a single cycle of 150 hours. They are very stable with the pH range of 3 to 12, and they had flux recovery ratio which is nearly 100%, so perform a very good anti-fouling property. To conclude, the non-stoichiometric PEC complexes enable fast for LBL assembly. Membranes show greater than 99.9% rejection of dyes, and they are suitable for low pressure, energy efficient textile wastewater treatment. Now to connect with the theme of our conference, Earth, Elements and Energy, it is a low pressure driven, low energy molecular separation, supports circular economy, that's dye plus salt recovery, and it is environmental friendly and scalable approach. Thank you very much.
Thank you, Urvashi, for nice presentation. Now the topic is open for discussion.
Question. So, Urvashi, you have used 2 polymers for this
Yes,
formation, 2 electrolyte.
Two polyelectrolytes.
Okay. So, in one case you take the homopolymer, another is a copolymer?
No, sir. Yes. These are the 2 polymers which are homopolymers only. One is the polystyrene sodium sulfonate, which is being produced by free radical polymerization. Another one is the vinyl imidazoles polymer, that is polyvinyl imidazole, which is after further quaternization with methyl iodide has produced quaternized ammonia, and that's being used as a cationic moiety, while this is being used as an anionic moiety. And these 2 are being used for the formation of polyelectrolyte complexes.
So, how many layers you are making out of this?
Only 3. That's the beauty of this work, that earlier literatures had reported 60 bilayers, means 120 total layer. And in this work, we are using 1.5 layer, that is only 3. So this is cost effective as it is requiring less polyelectrolytes, it is less time consuming, and I would say, as the title suggests, it's rapid in its nature.
And the spore size is smaller than the molecular size of dyes?
Yes, sir.
Okay.
Also, sir, one point to mention, dye undergoes aggregation.
Okay.
So only size base and charge base, both the phenomena for the separation are taking place over here.
Okay.
Yes.
Okay.
Thank you.
Nice. Yeah, thanks.
Thank you. Now I request Dr. Sujata Kavade for her presentation. This is the last presentation, and I request all, we will take a group photo at last of this presentation. So kindly inform to your friends, colleagues who have participated in this conference for poster and oral presentation in the session chemistry. Thank you.
Hello.
Copy paste? Paste. ओके ठीक आहे मग नेक्स्ट मॅडम करतील ना नेक्स्ट सो So good afternoon, respected dignitaries of the dais. It's a very difficult situation for me. Actually, I'm not from the field of chemical sciences. I'm from the field of life sciences. And I'm also a faculty of this particular college. But it was a privilege for me as we were having the conference at our own college. So I just tried to prepare a review presentation. And it's actually not a research presentation. So the topic for my presentation is green chemistry and sustainable development. Opportunities and challenges. Myself, Dr. Sujata Kawade from the Department of Zoology. Next, please. Very first introduction. As we all know, green chemistry is a design of the chemical products that eliminate the use and generation of hazardous substances. This particular program of green chemistry, it usually focuses on preventing the process of pollution, probably by applying principles like prevention of the waste, use of less toxic chemicals, and so on. So this particular approach in this particular study is to create a more sustainable chemical industry and reduce the negative impacts of this chemical industry on the human health as well as the conserving the environment. And as you people are all from the field of chemical sciences, we know that green chemistry is commonly presented by a set of 12 principles. Next, please. The very first one, as I came to know, the first principle is waste prevention, meaning better to prevent the waste than to treat or clean up the waste. So here, we can do it with the use of solventless sample preparation techniques. But here, as the name indicates, the topic is challenges. If you want to prevent the process of waste formation, there are high cost and complexity of new technologies and difficulty in developing the alternatives or the substitutes. Next, please. The next principle is atom economy, meaning chemical synthesis should be designed to maximize the incorporation of all the raw materials so that the products which are formed should not have any byproducts. So here, the challenge is it's really become difficult in a chemical process that all the raw materials should be used and no wasteful products are formed. Next, please. The next principle is less hazardous chemical synthesis. Here we are talking about the different methods that are used to generate substances with less or no toxicity to human as well as environmental health. And here the challenge is complexity of the molecules, that is the structural formulation of the molecule. It becomes difficult, so that is one of the challenge for the third principle. Next, please. The next one is designing of the safer chemicals. And here, it means that products should be designed to be effective while less minimizing their
toxicity, or they should be least toxic. Here, probably it can be done with the help of preparing less hazardous pesticides. Example is spinosad is a type of a biopesticide which is prepared from the soil bacteria, and challenges is difficulty of developing a precursor. Next, please. The next principle is safer solvents and auxiliaries. The use of auxiliary substances should always be avoided in order to implement the green chemistry program. And here, the challenge is difficulty in finding the proper replacements. Next, please. The next principle is design for energy efficiency. Energy requirements for a chemical process should be minimized. And here the challenges, the very first one is economic hurdles and a difficulty in optimizing the use of energy. Next, please. The next one is use of renewable feedstocks, meaning raw materials should be renewable rather than they should be depleting, or the use of fossil fuels should be usually avoided. Next, please. The next principle is reducing the use of unnecessary derivatives, but here the challenge is it requires extra reagents, more time, and energy. Next, please. The next principle is catalysis. Here, catalytic reagents are usually, I would refer biocatalytic agents should be usually used, but here the challenge is high cost of the material and limited substrate scope is the challenge which is to be faced for this particular program implementation. Next, please. Design for degradation. Biodegradation, chemical products should be biodegradable, and designing such biodegradable products are usually very much difficult. Next, please. Real-time analysis for pollution prevention. So this real-time in-process monitoring of the wastewater is usually done, but it really requires a high cost, and maintaining accuracy and reliability is very difficult. Next, please. Safer chemistry for accident prevention. So developing a chemical which is having less potential of chemical accidents, it faces challenges of high cost, lack of any alternatives. Next slide, please. Here I've prepared a slide which is showing advanced technologies like artificial intelligence, bio-based feedstocks, circular economy, developing environment-friendly formulations, developing biocatalysts, and use of green analytical techniques can be done for implementing this green energy, this green chemistry program. Last one. Requirements for this program is, it always requires a regulatory support. Policies and incentives from the government are required. Public awareness and interdisciplinary collaborative research are the basic requirements for its proper implementation. Last slide, please. Green chemistry, it is having a potential to revolutionize the sustainable development in chemistry and chemical technology with the use of industry, academia, and government. Despite its widespread scientific acceptance, this particular program is facing challenges like economic, regulatory, and technical barriers which can slow the process of this implementation. So from this particular present review presentation, I just want to suggest that green chemistry goals can only be achieved with the help of awareness and education, and much future research is required in this particular field.
Thank you, ma'am, for nice
Thank you.
presentation. And topic is open for discussion.
No discussion. We appreciate your effort.
Okay, sir,
Being a person from life science,
Yes, sir.
you presented your review kind
Yes,
of
sir.
thing here. Thank you so much. Thank you.
Yes, it really becomes difficult for me because while I was doing my BSc, I was across all these terminologies, but I still tried to prepare this particular presentation because we are having a number of students, research students, which are listening, and this is how we can create awareness for implementation of the green chemistry. Thank you very much.
Thank you so much, ma'am. There is one more presentation, that is Snehal Khandekar. Ali.
Okay, good afternoon to the respected judges, the organizing team, and the delegates. I am Snehal Khandekar from Indira Mahavidyalaya, Kadam. Today's I am going to give my presentation on the synthesis, photophysical characterization, and antimicrobial study of Zn2 complexes of NN-bis salicylidene ethylene diamine Schiff base. This is the overall outline of my presentation. Schiff base is first introduced by Hugo Schiff in 1864. It is nothing but the imines formed by the condensation of primary amines and aldehyde, and it is widely used in the coordination chemistry. It is gaining importance due to the strong coordination sites and having application in catalysis, optical properties, and the antimicrobial properties. Now, my work is depending on the ligands, Schiff-based ligand, which belongs to the silent type ligand, which is tetradentate ligand and has a strong ability to coordinate with the metal center. Now, why I have chosen the zinc metal? The zinc metal is biologically relevant and it is non-toxic in nature, and it enhances the ligand's optical and antimicrobial and photophysical properties. Now moving towards the experimentation, I have synthesized the zinc Schiff-based metal complexes by using bis-salicylidene ethylene 1,2-diamine by reacting with the zinc acetate in methanol under the reflux condition for 2 hours. I have done the characterization technique by XRD, same, Raman, UV visible, photoluminescence, and antimicrobial assay. This is the XRD and same morphology. In XRD, the strong peak shows the diffraction peaks, which shows that the complex is crystalline in nature, and the other new peak shows that the zinc is well coordinated with the ligand. Next is the same shows petal-like morphology. This is the Raman and UV visible spectra. In Raman spectra, at 2172 centimeter inverse, we can see that the zinc is well coordinated and the metal ligand framework is nice there. In UV visible spectra, we can see N to pi star, pi to pi star, and LMCT transitions, which shows that there is a nice electronic coordination between the metal center and the ligand. This is the photoluminescence spectra, where we can see 2 peaks at 542 nanometer and 609 nanometer, which shows that the metal complex is nice for the luminescence property and sensing application. This is the antimicrobial assay of the zinc Schiff-based metal complex, in which we can see the antibacterial activity enhances by increasing the doses, as well as the antifungal properties also increases by increasing the doses. Here we can see the antibacterial activity is not that much pronounced, but the antifungal activity we can see with increasing doses, we can see the antifungal activity. These are the various applications of the zinc Schiff-based metal complex, that is optoelectronic devices, fluorescent sensor and chemical probes, antimicrobial coatings and materials, biomedical applications, UV absorbing and photostabilizing agents, catalytic applications, and nanomaterial and surface engineering applications. Now at conclusion, I will say that I have prepared the zinc metal complexes successfully. It has a nice crystalline structure and petal-like morphology, and it shows nice photophysical properties and moderate antimicrobial activities. Thank you.
Thank you. Have you published this work?
Not yet, sir.
Okay. Okay, thank you.
Thank you so much.
Can you go to this photoluminescence spectrum? So this is for which compound?
Excitation, emission.
No, for which compound this spectra you got?
Zinc shift-based metal complex.
So zinc shift-based metal complex, why it's giving very sharp peak? Generally photoluminescence spectra should be broad spectrum. It should not be like this. Only lanthanide compounds or some of the actinide compounds can give the sharp peaks like this.
Sir, I have read I have taken references of the so much papers.
Mhm.
There we have said when there is a ring structure or what we say conjugated system, it can show the photoluminescence property. So I check it for check for the photoluminescence property.
Yeah, but this what I am saying that we cannot get very sharp peak in photoluminescence for the zinc complex. Zinc complex of ship base, you have silent type of ligand, so that will not give this type of sharp peak. It should be always a broad peak. So sharp peak can get only for the either DD transition or FF transition in
This is for
length.
the DF transition.
Yeah, we don't have the DD transition in zinc complex. It's a D10 system, right? Okay.
Thank
Thanks.
you so much. I request respected judges, please be come on the dais just for 2 minutes, sir. तुम बाहेर आहे. हे camera
एक फोटो निकाल लेते आपण जाऊ ना आपलाच फोटो काढा झाले सर एक मिनिट
We are going to begin the program in just a few minutes. The guests are on their way. A very warm good afternoon to all. Honorable dignitaries are arriving in the hall. Welcome all to the valedictory function of National Conference on Earth, Elements and Energy, Interdisciplinary Perspectives 2025, organized by the Departments of Chemistry, Physics and Geology. At the outset, I pay heartiest tribute to the founder president of Sri Shivaji Education Society, Dr. Panjab Rao alias Bhau Sahib Deshmukh and Karmayogi Gadge Baba. I, Vaishali Deshmukh, welcome our distinguished guests, delegates and fellow science enthusiasts to the valedictory function of the National Conference on Earth, Elements and Energy in the Disciplinary Perspectives 2025. We count ourselves extremely privileged to have the opportunity to host a gathering of esteemed scholars from all over India. Let's take a moment to appreciate the incredible discussions and insights shared among the scholars for exploring the intricate relationships between earth, elements and energy, aiming at more harmonious and sustainable future. We are extremely happy to have with us renowned dignitaries who have carved a niche in their respective fields. We would like to express our joy and gratitude by welcoming the distinguished guests. We have among us the principal of Sri Shivaji Science College, Amravati, Dr. G.V. Korpe, as the chairperson of the valedictory function. I request Dr. P.R. Mandlik, convener of the conference, to welcome him by offering a sapling. A plant nurtured by earth and elements and dissipating energy among all living beings. Indeed, what an apt token of reverence to be presented to the guests. Thank you, sir. Now I request Dr. P.A. Nagpure, sir, organizing secretary of the conference, to welcome Dr. Sanjeev Zhade, Department of Chemical Sciences, IISER, Kolkata. Welcome, sir. Now I request co-convener of the conference, Dr. Mayura Deshmukh, madam, to welcome Dr. Shivaji Sadale, who has been working as a professor in the Department of Technology, Shivaji University, Kolhapur. Thank you, madam. I welcome Professor Dr. S.P. Ingole, IQAC coordinator, Dr. P.R. Mandlik, sir, convener of the conference. Yes. I request Ingole madam to welcome Dr. Pramod Padole, sir, principal of Sri Shivaji Science and Arts College, Chikhli. Welcome, sir. I welcome the organizing secretary of the conference, Dr. Nagpure, sir, co-coordinator Mayura Deshmukh, ma'am, Dr. Dinesh Khedkar, sir, coordinator of DBT STAR. And once again, I welcome the delegates and all the people present here. The entire campus of Sri Shivaji Science College has been reverberating with the intellectual discussions and thought-provoking ideas since yesterday. Let's hear about all the happenings that took place in the conference. I request Dr. P.A. Nagpure, organizing secretary of the conference, to present conference report.
Of the valedictory function, respected Dr. G.V. Korpe, principal of the college, respected dignitaries on the dais, the chief guest of today's program, Dr. P.R. Padode, the principal, Sri Shivaji Art, Commerce and Science College, Chikhli, Dr. Sanjeev Zhade, Department of Chemistry, IISER, Kolkata, Dr. S.B. Sadale, Director of International Linkages, Shivaji University, Kolhapur, The convener of this conference, Dr. P.R. Mandlik, Dr. Sangeeta Ingole, IQAC coordinator of the college, Dr. Mayura Deshmukh, the head of the Department of Geology, Dr. Dinesh Khedkar, the coordinator, DBT Star College Project, delegates, faculty, colleagues, research scholars, students, ladies and gentlemen. It is my privilege to present the final report of the National Conference NCE3IP, National Conference on Earth, Element and Energy, Interdisciplinary Perspectives 2025, jointly organized by the Department of Chemistry, Physics and Geology of this college. This two-day conference brought together experts, academicians, scientists, researchers and students from diverse specializations to deliberate on interdisciplinary perspectives related to earth, elements and energy. I am pleased to share the important highlights and outcomes of this event. In all, we have received total 496 registrations. Out of it, the 242 are the faculty members and scientists from the various institutions. The research scholars, PhD students are 251. The number of delegates from the outside of the Maharashtra, which signifies that this conference is truly a national conference. The total number is 6. Discipline-wise participation is, total registrations in chemistry are 276, in physics it is 120, in geology it is 93. Total number of invited speakers were 16. Among this, within state were 11, from the outside state 5. Total number of sessions conducted are 17. Technical sessions were 16, keynote session is 1. Total research presentations, oral presentations in chemistry were 16, in physics there were 16, in geology there are 9 presentations. Total poster presentations are 235 in chemistry, in physics there are 72 presentations, in geology there were 68 presentations. Participant presents high quality research, work covering areas such as material science, sustainability, environmental studies, energy system, computational approaches towards the sustainable energy, geological processes. The sessions were highly interactive, enriched with meaningful discussions. In this conferences, to encourage the young researchers, we have to give some awards. So that will be given by the organizing committee of this conference. So in this, there are total 6 awards will be given to the researchers for the oral presentation, best oral presentations, and for best poster presentation there are 6 awards to be given. The evaluation committee comprised of senior academicians, subject experts who assess this research contribution based on scientific contents, clarity of presentations, innovations, relevance to the conference theme also. And about the overall outcome of this conference, the conference successfully achieved its objective of providing the multidisciplinary platform for exchanging the ideas, discussing emerging fields, and fostering collaborations among chemistry, physics and geology faculties and scientists. The enthusiastic participation of delegates from various institutions and states reflects the academic significance of the event. Thank you very much.
Thank you, sir. The conference report reflects the tireless efforts taken by all the stakeholders of the conference and energetic involvement of the delegates directed towards the betterment of humanity through their research. Thank you once again. Now I request Dr. Shivaji Sadale, our guest of honor, to express his views on the occasion.
So, good evening. Dignitaries on the dais, dignitaries of the dais, and other faculty members and my dear student friends. It's indeed pleasure to be in Amravati and in Shivaji Science College. I congratulate principal and the other organizers and his team for organizing such an event by combining 3 subjects, which is the need of an hour. The students should get exposure to interdisciplinary approaches, what's happening and what are the developments in the other subject, because the real life is indeed a mix of all the subjects, where I cannot say this is not my subject and so. The challenges the student has to face in his life, they are with all the subjects. There, even if he has not studied commerce, then also he need to use the knowledge of commerce for the ease of his life. And that is why I particularly congratulate Sri Shivaji Science College for taking initiative in organizing the conferences, interdisciplinary conferences. And as we have gone through the report and I seen the enthusiasm among the students, I hope the students have enjoyed all the deliberations, and you might be eagerly waiting for the awards. And once again, I wish everyone all the best in their careers and be successful. Thank you all.
Thank you very much, sir. It is said that wisdom is knowing what to do, skill is knowing how to do, and virtue is doing it. Dr. Sadale, in his speech, motivated all of us to do good things in our lives. Thank you once again, sir. The entire organizing team of the conference put in a lot of hard work under the meticulous leadership of the principal of the college, Dr. G.V. Korpe. No doubt our efforts culminated into a grand success. However, we are very much eager to listen to the participants' views to make our future efforts more pointed and effective. I now call upon the delegates to express their views, to give their feedback. From the chemistry department, I invite Dr. Urvashi Joshi from Central Salt and Marine Chemicals Research Institute, Bhavnagar, to give her feedback.
Very good evening all. Myself Dr. Urvashi Joshi, and it was an absolute pleasure to participate in National Conference on Energy, Earth, Energy and Elements, Interdisciplinary Perspectives 2025. I would like to sincerely thank Sri Shivaji Science College Amravati and the entire organizing team for arranging such a vibrant and well-executed conference. The interdisciplinary theme was highly relevant and the presentation were of excellent quality. The event offered a meaningful platform for scientific exchange, collaboration and new ideas. The hospitality, the venue, arrangement, session management and overall coordination were exceptional. I truly appreciate the immense efforts put in by the organizers, faculty and the volunteers. I look forward for being part of such conferences in the future. On the personal note, being an alumni of this college, I have completed my bachelor's and master's from here, and I am a 2019 pass out. So after coming back to here, almost 6 years, so I see a lot of development in the college, especially in the terms of infrastructure. Again, the Central Instrumentation Center and the Research Center, which is under development. I appreciate all the efforts taken by the organization committee and Sri Shivaji Science College. And special thanks to my Department of Chemistry and PG Department of Chemistry. Whatever the heights and things we are doing in our career, the building block and the foundation were you. So I extend my heartful thanks to all the faculty members of the Department of Chemistry and all the faculties from Shri Shivaji Science College, Amravati. Thank you so much.
Thank you very much, madam, for your wonderful words of appreciation. Now I invite Mr. Satish Atole to express his views.
So very good afternoon to all of you. My name is Satish Atole from Government Vidarbha Institute of Science and Humanities, Amravati. Especially I am not fluency in English, but I am trying to express my feedbacks to this institution because I am the former student of this institution, and I am let me know in speak in Marathi. तर इथं मी या स्टुडंट या कॉलेजचा मी 2000 आय थिंक सर सहाच्या बॅचचा 2011ला मी पासआउट झालो इथून 10-11 आणि काही लोक इथं मला दिसत आहेत, काही लोक नाही आहेत, मे बी रिटायर्ड झाले असतील. आणि ज्या लोकांमुळे मी इथं आज उभा आहे आणि तुमच्या समोर बोलत आहे ते सगळ्या जे श्रेय आहे ते श्रेय हे इथे बसलेले जे रिस्पेक्टेड डॉक्टर प्रशांत मंडलिक सर आहेत, रिस्पेक्टेड डॉक्टर PA नागपुरे सर आहेत, आणखी सरांचं नाव पडोळे सर आहेत, रिस्पेक्ट डॉक्टर पडोळे सर आहेत, आणखी जे आहे लीलाधर गावंडे सर जे आपल्यात नाहीत आहेत, आणखी मी सगळ्यांचे नाव माझ्या लक्षात नाही आहेत, बनसोड सर आहेत. यांमुळे मी इथं आज उभा आहे. आय एम नॉट अ फिजिक्स स्टुडंट, आय एम अ फिजिकल एज्युकेशन स्टुडंट. बिकॉज आय प्ले इन क्रिकेट, आय लव्ह क्रिकेट, आय प्ले क्रिकेट एव्हरी टाइम. माझ्या डोक्यात ते क्रिकेटचंच चालतं. पण ड्यू टू सम रिझन आय एम जॉईन द रिसर्च, आय जॉईन द PhD. ते म्हणतात ना सर, एक असा क्षण असतो की तुम्ही त्या ॲक्सिडेंटली त्या क्षेत्रात जाता. मला कोणी म्हटलं होतं PhD करणं तोंडाचा खेळ नाही आणि ॲक्सिडेंट तुमच्याकडनं होत नाही, या पोलीसवाल्यांचा पोरगा आहे, होईल नाही होईल. म्हटलं ठीक आहे, बघू काय होते. तर गावंडे सरांनी मला एकच शब्द बोलले होते की सतीश तुझ्यात सगळं काही आहे आणि तू करू शकतं. तर ते शब्द मला भावले. त्यांनी थोडा सपोर्ट केला. तुला सपोर्ट करण्याची आवश्यकता नाही, मी फक्त थोडं पुश दिलं, म्हटलं तुम्ही सगळं काही करू शकता. त्याचप्रमाणे जे काही इथे ज्यांचे मी नावं घेतले, ज्यांचे घेतले नसतील ते पण आज मी ज्या एवढा मोठा नाही आहे, पण मी ज्या स्टेजवर मी तुमच्या समोर एवढ्या मोठ्या लोकांसोबत मी फर्स्ट टाइम बोलत आहे. मी कधी स्पीच दिलेले नाही, मी कधी सेमिनार्स दिलेले नाही, मी कधी पोस्टर प्रेझेंटेशन केले नाही, आज केलं. याचं श्रेय या सगळ्या लोकांना जातं, या इन्स्टिट्यूशनला जातो. आज मी विद्यापीठामधून पासआउट झालो, श्री शिवाजी सायन्स कॉलेज अमरावतीमधून पासआउट झालो आणि VMB कॉलेजचा मी आता सध्याचा स्टुडंट PhD स्टुडंट आहे. म्हणजे जे काही टॉपमोस्ट स्टुडंट आहेत इन्स्टिट्यूशन्स आहेत, इन्स्टिट्यूशन्समधून मी पासआउट झालो. आणि इथं उभं राहण्याचं श्रेय सगळ्यांना आहे. आणि कॉन्फरन्सबद्दल बोलायचं जर म्हटलं तर कॉन्फरन्स हे अतिशय सुरेख झाली. सगळ्यांचं कौतुक करतो की सगळे जे टीचिंग स्टाफ आहेत, मॅनेजमेंट कमिटी आहे, कोरपे सर आहेत, यांनी एवढी मोठी नॅशनल कॉन्फरन्स घेणं काही तोंडाचा खेळ नाही. नॅशनल कॉन्फरन्सला मॅनपॉवर लागतं. मॅनपॉवर म्हणून तुमचं कोलॅबोरेशन्स लागतं, तुमचं कम्युनिकेशन्स लागतं. इफ यू आर नॉट कम्युनिकेट टू इच अदर, आज आपण बघतो जर कम्युनिकेशन नसेल तर डिपार्टमेंटसुद्धा चालत नाही सर, घरसुद्धा चालत नाही. पण तुमचं एवढं आमच्यापासून, म्हणजे मी जेव्हापासून शिवाजी सायन्स पाहतो एवढं चांगलं कम्युनिकेशन कदाचित कोणत्या इन्स्टिट्यूशनचं असेल. सो आय एम व्हेरी मच थँकफुल टू ऑल respected teachers, non-teachers, those who are made successful in this conference, also participants. सरांनी सांगितल्याप्रमाणे 496 म्हणजे पूर्ण लोक प्रेझेंट होते इथं. त्याचे सगळ्यांचे धन्यवाद देतो. आणि मी माझ्या डिपार्टमेंटला पण माझे धन्यवाद देतो की मला इथं परमिशन दिली की माझं रिसर्चवर पब्लिश करायची. आणि थांबतो. थँक्यू व्हेरी मच.
Thank you, Mr. Atole, for expressing your genuine feelings. Now I call upon Mr. Pawan Chikhalkar, research scholar from Department of Geology, Sant Gadge Baba, Amravati University, Amravati, to express his views.
Thank you, ma'am. First of all, good evening, all my respected mentors and my friends. First of all, thanks to Shivaji Science College, convener of the conference, and all co-conveners, especially Dr. Mayura Deshmukh ma'am, for organizing such wonderful conference and providing us a platform to represent our work. On talking on the conference, so all the technical sessions were very informative, and because of that I come to know new ideas in research field. In case of dinner, lunch, so all the facilities were excellent. I am very fortunate that I am again alumni of this college, because after 9 years I come to this college and it is totally changed. There are many changes I can see here. There is my one expectation that I hope the college will organize such more programs so that we all get such opportunities to represent our work here. Thank you so much. Thank you, sir.
Thank you for your suggestion. Now let us move on to the most awaited part of the program, announcement of winners in the oral and poster presentations. I request honorable guests to present memento and certificates to the winners. The winners in the oral presentation, from the chemistry department, the first prize goes to Palak Trilokchand Bhattad. Congratulations. The second prize goes to Miss Vaishnavi Gidmare. The consolation prize goes to Dr. Urvashi Joshi. Hearty congratulations. Now the winners from the physics department. The first prize goes to Sanket Korde. Congratulations, Sanket. The second prize goes to Sapna Razankar. Sapna Razankar. Congratulations. Now the winners from the geology department. The first prize goes to Vikas Dnyaneshwar Ghadamode. Congratulations. The second prize goes to Mr. Pavan Chikhalkar. Now the winners in the poster presentations. From the chemistry department, the first prize goes to Madhuri Balpande. Madhuri Bal Pandey. Congratulations. The second prize winner is Nilesh Govindrao Jadhav. Congratulations. And the consolation prize goes to Akash Vijay Kubde. Akash Vijay Kubde. Is there anybody who could collect the prize on his behalf? Now the winners from the physics department. The first prize goes to Mr. Vishal Bise.
हे प्राईज जे भेटलेलं आहे मला याचं क्रेडिट जे आत्ता ज्यांनी वोट ऑफ थँक्स दिले होते त्यांचं आहे, जे आहे सतीश कुमार आठवले. ते जरी म्हणत असतील की मला काही येत नाही, पण ते FTRमध्ये टेक्निकल सेक्शन जे आहेत ते त्यांनी आत्तापर्यंत FTR, XRD आणि जे काही कम्प्युटेशनल स्टडी आहे तो त्यांचा एवढा स्ट्रॉंग पॉईंट आहे. जरी ते क्रिकेट खेळत असतील पण त्यांनी इथेही क्रिकेट खेळलेली आहे. मी त्यांना बोलू इच्छितो, सतीश सर प्लीज कम ऑन स्टेज. आणि सर्वात सगळ्यांचं अभिनंदन. आणि नागपुरे सरांचं खूप चांगलं इथे ऑर्गनायझेशन जे आहे ते झालेलं आहे. त्यानंतर प्राचार्य सर, कोरपे सरांचं खूप छान इथे व्यवस्थितरित्या सगळं जे आहेत. आणि सगळ्यात जास्त चांगलं म्हणजे डिनर खूप मस्त झालेलं आहे. सगळ्यांचे धन्यवाद.
हा सरांचा मोठेपणा आहे की ते बोलताय तसे, त्यांना प्राईज त्यांचंच आहे ते.
Congratulations to both of you. Mr. Satish Atole, you please stay here because second prize goes to Satish Atole.
आमचं साडा लोट चालू आहे आता. आणि हे प्राईज माझं नसून कसं एका हाताने टाळी वाजत नाही, म्हणून हे जे काही आमचं श्रेय आहे हे त्या सरांना तर जातंच, पण हे आमच्या दोघांना पण जातं. थँक्यू व्हेरी मच.
Congratulations once again. Now the winners from the Department of Geology. The first prize goes to Meet Ambekar. Congratulations, Meet. And the second prize goes to Sania Dupatte. We feel proud that both these students are the students of Sri Shivaji Science College. They are the students of BSc second year. Sania Dupatte. Congratulations to all the winners. May your scientific excellence pave the way for new horizons in your future. Congratulations once again. We are honored to have with us Professor Dr. Sanjeev Zhade from Department of Chemical Sciences, IISER, Kolkata, As the chief guest of our function, I request him to express his views.
Good evening, all. So it's an honor to stand here as a guest for this particular valedictory function of National Conference on Earth, Element and Energy, Interdisciplinary Perspective, NCE3IP 2025. So, basically, Mandlik sir told me not to speak more than 2 minutes here. So that's why I am taking time 1 minute to introduction and 1 minute to say thank. So it will be completed my speech. Okay, so what happened, once a very renowned speaker has come and one faculty member has given the job to introduce that speaker. कि आप उनको introduce कीजिए. So he went on the dais, he said that, so today's speaker is very big speaker, everybody knows him, I don't need to introduce. And उन्होंने सही में introduce नहीं किया उसको, then started. So my situation is just like that. I have to say nothing to here because it's so let's talk about the conference. So what makes the conference great? That is the question that we have to. When we start with conference, we ask same question, and if we end with a good note, we also ask same question: what makes conference? Conference make great the good food, good delicious food, right? Good music while awarding the while awarding the prizes, and good tea between the session. What else? So these all are basically secondary thing, but this makes one impact on the conference. So what we put together is efforts. For example, the student who came to take a prize and he invited his co-worker, friend to share his prize. So basically that is the spirit. That is the basically make conference great actually. So apart from that, conference conference become great when there is a coordination between the people. And this particular conference is a very best and unique conference where 3 departments are coming together: chemistry, physics, and geology. All 3 departments are coming together, putting efforts together. Many times you see that there is always चढावळ असते वेगवेगळ्या डिपार्टमेंटमध्ये, coming together, bringing together. So we should hats off to the principal of the institute who basically done this job very meticulously, and he's still cheering all people. You can see from the dais cracking some jokes and saying something. So this is a very big task actually. I also should congratulate all three conveners, Professor Mandlik, Professor Nagpure and Professor Deshmukh from all 3 departments, because they have done great job. Obviously, the conference main aim is basically to bring people together, exchange ideas. And I want to make some suggestion. I am quite hesitant to make a suggestion. Or inauguration, valedictory function should be the great. But inauguration, there should not be very elaborate inauguration, spending a lot of time on the inauguration. So it's a short, sweet program, and then more time for the scientific deliberation. That will basically make, we can accommodate more speakers, we can give the more time to poster presentation, oral presentation. So that way we can also, some point we can improve it will make even, it will take the conference even higher heights. Another thing is basically our exchange of ideas. When we talk, exchange, and this will be immensely beneficial for the young minds, new people. So many students, they are starting the PhD and they have done small work and presenting the poster. Now if somebody presenting poster and he is explaining his work, it's an immense pleasure to explain done own work, explaining in front of the people who are from the different field with a different level. So that is basically a great thing. That way the students will get confidence. And by exchanging idea, they will also come to know what's going in the field, what other people are doing. And that basically, so this will be the great inspiration for young people, so they can put their efforts in proper direction and they will also get motivated. Many people, when they finish 1 year or 2 years, they get frustrated that some results are not coming, things are not working. So that way, arranging conference. And in inauguration, we had very diligent speaker, Professor Muske from ICT Jalna. He basically very specifically pointed out that the conference has, means for example, the colleges has to cater the education to many students. So doing education and also doing the cutting edge research is really the very tough job. And it's also not expected that colleges should do the very high level research, because we don't have the facilities, we don't have that kind of fundings. But what makes the college difference is making the platform for students to go the higher heights. Yeah? And that this conference has basically done this job very nicely, very particularly. And I congratulate all the organizers, the principal of the college and all organizers. With this, I end my 2 words. I think I have finished 2 minutes. Thank you all for listening.
Thank you very much, sir, for your words of wisdom. Now I invite Dr. Dinesh Khedkar, sir, to make an important announcement.
Dignitaries on the dais and off the dais, I'm here to encash this opportunity. As you people have enjoyed 2 days national conference in this campus, we are extending one more opportunity for all of you. In the January 23rd and 24th, we are hosting National Students Congress. This is for the first time any institution is focusing on the research conducted at the undergraduate level, graduate level and post PG level. So all the students are having good opportunity to interact with the students from all over India. We have just made an announcement before 2 days and we have received around 200 responses from various states, and this will be a great opportunity for all the UG students especially, and then for the PG students to share their research work. And to participate in this conference, what may be the way to come forward? We are sharing our ideas in 1 day workshop, which is the pre-Congress workshop, which we have organized on the 8th of December. This 8th of December will have the workshop wherein we'll elaborate what exactly is the concept of the Congress and what exactly student has to do in the next few months to join this Congress. You might have gone through National Congress, Indian Science Congress, wherein laureates are presenting their research work and students are participating there as the audience. But here this will be a Congress on the same line, which will focus on the research at the undergraduate level, and this research, this Congress will not be focusing only on research. There will be another 3 focal points of the Congress, and that are education, what exactly are the requirements or what exactly are your suggestions in the entire education system. Secondly, for the innovations, and thirdly, for the entrepreneurships. So these are the 3 areas beyond research we are focusing in this Congress, and you people, those who have won the award and those who have not won the award, they all are invited for this Congress to share their research, and this will be definitely a great opportunity for you to build a stronger network, because here we are inviting mentors from the various sectors, those who are great researchers, innovators and the entrepreneurs. So I would like to invite your attention to our college website, wherein entire details are placed, and you will visit there. Primarily you need to do one thing, that please register for the 1 day pre-Congress workshop which is scheduled on 8th of December, wherein you will get the entire conceptual understanding of this Congress, and then you will register for the actual National Science Congress, National Students Congress actually. It is not only meant for the science students. This will be a Congress for all the students which are from the different lines of education. So once again we'll be ready for welcoming you all in this wonderful campus. Thank you. Thank you very much.
Thank you, sir. Now I request Honorable Dr. G.V. Korpe, Principal of Sri Shivaji Science College, Amravati. I request Dr. Pramod Padole, sir, to speak a few words on this occasion. We are eager to listen to you, sir.
Good evening to everyone, all the dignitaries on the dais, of the dais, all my colleagues and all participants. It is a great honor for me to here today as the chief guest for this valedictory function of this National Conference NCE 3 IP 2025. This conference on Earth, Elements and Energy has been very meaningful. The presentation and discussion over the past days showed how different subjects can come together to solve important issues like energy needs, environment protection, and sustainability. I would like to congratulate the organizer for successful and smooth management of this event. I especially thank Principal Dr. G.V. Korpe sir for his guidance and leadership. My appreciation also goes to the convener and his hard-working team who planned everything so well, from registration and hospitality to all the technical sessions. Their teamwork is truly commendable. I also feel a special connection with this college. Before joining Sri Shivaji College Chikli as a principal, I was once a part of this wonderful institution. Coming back yesterday feels like returning home. I was the PM Usha coordinator of this college when I proposed this conference in this proposal under the soft component activity. This conference has given a good platform for teacher, researcher, and student to share ideas. I believe that this knowledge gained here will encourage new research and useful collaboration in the future. Once again, I congratulate everyone involved and extend my best wishes to all participants. May this institution continue to shine and contribute to society. Thank you. Thank you.
Thank you very much, sir, for your encouraging words. Now I request Dr. G.V. Korpe, sir, to deliver his presidential speech.
A very good evening to one and all. At the outset, I pay my sincere tributes to Founder President of Sri Shivaji Education Society, Dr. Punjab Rao alias Bhausef Deshmukh, Karmayogi Gadge Baba. I know this is the last part of the conference and everyone is looking for their return journey and waiting for the program to get over. But that is the job given to me as a chairperson for this session. So on the dais, Dr. Shivaji Sadale sir, Dr. Zade sir, IQAC coordinator Dr. Ingole madam, convener of this conference Dr. Prashant Mandlik, Dr. Nagpure, DBT star coordinator Dr. Dinesh Khedkar, then former PM Usha coordinator and principal of Sri Shivaji Arts and Science College Chikli, presently is working as a principal. Then presently who is working on PM Usha, that is Dr. Manish Gaikwad, he is now working as a coordinator of Pradhan Mantri Uchchatar Shiksha Abhiyan. Heads of the department, invited guests, dear students, I congratulate you for being part of this conference, interdisciplinary conference that this college has organized. I take this opportunity to thank all my colleagues, my teachers, then non-teaching staff, research student, UG, PG students, students from NCC cadets, NSS, each and everyone, the person who is looking after the catering, then sound service, Joshi Kaka is sitting in front of his, here he is there for 2-3 days. And it was really, I may say, it took a lot of pain, mainly for convener and organizing secretary, Dr. Nagpure, to organize and to make this conference a great success. Each and every conference, we are just organizers, but the success comes when delegates like you visit or register for this conference. So I congratulate Dr. Mandlik sir, Dr. Nagpure sir, also Mayura Deshmukh madam, head Department of Geology, the third department which is participating in this conference. Also Dinesh has given you some information about the student congress that we are going to organize on the 23rd and 24th January this next year, that is 2026. That was really a great idea because we thought that teachers and research students, they get some platform now and then to present their work. What we are hoping in this congress is to invite such students who are not even registered, but they are having good ideas. They may be from humanities, they may be from commerce management, or they may be doing some other job. They might not be research student, but they are having a very nice ideas, very good ideas. So for them we are planning, and it's a national level event, so we are planning to invite each and every innovator and provide him a platform and to discuss his stories, whatever he has done up till now. So let's hope that event will be also a great success. I am again thankful to all of you for being the part of this conference. Thank you very much.
Thank you very much, sir. Let's carry the knowledge, inspiration and connections forward and continue to push the boundaries of science and innovation for a better tomorrow. Now I call upon Dr. P.R. Mandlik, sir, convener of the conference, to express vote of thanks. The program will conclude with the national anthem after the vote of thanks, so all are requested to be seated till the end.
Good evening, each and everyone present here. Please bear, I know that all are you tired, so please bear 2 to 3 minutes for me. Actually, there is no limitation to the convener about the time, but I am restricting myself. At the outset, I pay my homage, my sincere homage to Founder President of Sri Shivaji Education Society, Dr. Panjabrao Alias Bhausaheb Deshmukh, Karmayogi Gadge Maharaj, dignitaries on the dais, of the dais. It was really a great time with all of you. I hope that you have enjoyed the 2 days conference. On behalf of organizing team and my own behalf, I would like to extend my sincere thanks to everyone for your kind presence today for both these days. We must express our deep sense of appreciation for today's chairperson, Honorable and respected, beloved Dr. G.V. Korpe sir, our principal, for accepting our invitation and for his consent to grace this occasion as a chairperson. We would like to acknowledge our gratitude to Chief Guest, Honorable Dr. Sanjeev Dhade sir, Professor, Department of Chemical Sciences, IISER Kolkata, and Dr. Shivaji R. Sadale sir for being kind enough to spare some valuable time with us. My sincere thanks to today's guest of honor, Principal Dr. P.R. Padole sir, who accepted on-time invitation and graced this function. Conference as a whole, I must express a big thank to our keynote speakers, invited speakers, chairpersons, juries, all the scientists, delegates, all the researchers. Without their support, it was not possible for a successful organization of this conference. My special thanks goes to our respected principal, Dr. G.V. Korpe, for believing in us and untireless cooperation and support in planning and execution of this mega event. I also extend my deep sense of gratitude to the IUPAC coordinator, Dr. Ingole ma'am, DBT coordinator, Dr. Khedkar sir, PM Usha coordinator, former PM Usha coordinator, Dr. Padode sir, and present PM Usha coordinator, Dr. Manish Gaikwad, for their painful efforts for success of this 2 days event. I would like to extend my sincere gratitude towards all the conveners of functional committees and committee members also. I would like to express my gratitude towards the principals of various colleges, heads of the departments and colleges for granting permission to their research students to attend this popular talk and all the events planned therein. I would like to extend my sincere appreciation to all the artists who performed in cultural program and entertained us in yesterday's evening. I also appreciate the efforts taken by all the anchors who conducted the sessions, different sessions, and all the students who assisted the sessions with the session for smooth conduction of all the sessions of chemistry, physics, and geology. At the end, I express my sincere thanks to the person seated before the dais and his entire team for holding audiovisual responsibilities on both these days. Thanks are also due to all the media persons who have taken efforts to render this event the media coverage. At last, I am thankful to all those teachers, non-teaching staff who directly or indirectly help in organization of this academic task. Thanks everyone for being a part of this amazing journey. Thank you very much.
Thank you, sir. Thank you all. The program will conclude with the national anthem. I request all to stand up for the national anthem.
मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तब जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Bharat Mata Ki. With the permission of the chair, I declare that the program is over. I request all to enjoy high tea. Have a wonderful day.